you cannot access all the things.
Yeah. So student version, there will be certain limitations. You can't use more than 100 observations. But as far as R Studio is concerned, you can use any number of observations. And see, again, coding in R requires that you need to have some sort of love for this particular software. Because what my understanding is that if you don't love this particular software, or if you're not in love with this software, you will find that coding will be very cumbersome. And if you are used to this drag and pull, or select and drag and then get the output by the click of a button, then you may find that R will be very difficult. By the way, in the coming time, I'm going to circulate a survey in order to
Okay.
understand that what is the people's compatibility to use R and R Studio in their research analysis. So what is their level of understanding, and will they feel like using it in their research analysis? So I will floating a survey, or there is also one more thing called intention to use R Studio, or intention to use R. So you can
Right,
you
right.
can create multi items, and you can have lot many variables. So what my understanding says, no, Dr. Love, that there are many senior and seasoned researchers also, they shy away from using R and R Studio. I don't know why, but maybe they have access to all proprietary softwares, and they're used to it, like how I'm used to
Sir,
R
actually,
Studio.
the when
Uh,
the statistics fundamentals are poor and you are not well versed with statistical analysis,
uh, uh,
basic analysis, fundamental analysis, you are poor
yes,
to comprehend something from the results.
yeah.
And one more thing, you are not ready to use the new tools. You're
Yeah,
not ready to accept the new things. Like
yeah,
R is like you should know the basics of R, that how to
yeah,
handle the script and how to handle the files which you are going to import.
yeah,
Then you
yeah,
should know the primary information. Then you can use the advance of
yeah.
it.
And by the way, R is becoming super easy now. So now, if you focus, earlier there was a Lawan package for CBSEM, and
Correct, sir.
PLS-PM package for PLS-SEM. Now what they are doing, they're combining most of the analysis into one package. Yes. Okay. So that's the beauty. So there are 4 or 5 packages that you need to learn it. And after learning these 4 or 5 packages, you will see that R is pretty easy. It is very easy. And also, to add to what Dr. Love said, now there are universities in their formative years, they're making it mandatory for the research scholars to learn R. So now you can see that there will be, in times to come, that there will be lot many people who will be using R. By the way, to just to add on to this discussion, a couple of years back, I think 3 years back, I had gone to IIM Ahmedabad when I was writing my PhD thesis, and I was doing my analysis. And when I took a stroll in the library, I could see lot many people were using R. Lot many people. So I used to stand beside them and see how they were coding and all. And I used to ask them questions. So how are you doing it? So people are doing so many things in R, because what is the beauty of R is that it is one such software which can handle everything: qualitative research, quantitative research, social network analysis, meta-analysis, bibliometric analysis, text analytics, content analytics, sentiment analysis, even website data analysis. So R can do everything. That's why there is a lot of fascination, particularly among new research scholars to learn R and take up this in their analysis. And I would also suggest that see, there is nothing harm in using any software, be it a paid one or be a non-paid one, but it is always better to have your hands on this kind of software, particularly open source like R and Python, and also go back and teach to your students. Particularly, let's say if you're teaching MBA students, or for that matter undergrad students, or for that matter your PhD students, so you can go and teach them. So even they will be understanding. And by the way, there are a lot many e-contents available on variety of platforms regarding R. So R is something that you can self learn on your own. You need not depend too much on any resource person, because knowledge is highly democratized, and YouTube is the biggest source where you can go and not only learn R, but you can master R. And by the way, let me tell you that when I started learning R in December 2017, so I've been learning R. My first interface with R was in December 2017. So I started watching this IIT Kanpur Professor Shalab's video, which is heavily there on YouTube. So Professor Shalab's video really helped me a lot. And later on also Professor Neeraj Kaushik has done a wonderful job on in R&R studio. So his video is also very helpful. So initially I watch Professor Shalab's video, then Professor Neeraj Kaushik's video. Then there is one video by Mike Merrin. Mike Marin, even he speaks in English, and even he gives a wonderful analysis. Then there are videos by Mike Crossan. Then there are videos by uh, James Gaskin. So there are a lot many Indian researchers, and for that matter, foreign researchers. They have done an excellent work in R. And by the way, you simply type anything, let's say logistics regression in YouTube, you'll get a lot many commands and syntax. And there are people who upload their syntax also for the benefit of the research community. You simply need to download the syntax and accordingly change it according to a data file and run your analysis. So it's a beautiful thing that you can do about R. Okay, and R is particularly very good for data science. And again, the purpose of this workshop was to keep you on your toes. So that yes, R is something which is within your reach and you can manage it very easily. Like I think Felix sir knows R very well, and I think I have also seen Felix sir on NPTEL and this SWAYAM platform. So he can definitely create some content on R, and he can maybe in his place, and you can upload on the SWAYAM portal. So lot many people also benefit, and you can also start your YouTube channel for the benefit of the research community. See, by the way, whatever I'm teaching in this particular workshop, I'm uploading on the YouTube. So let's say tomorrow, even if I'm not there, my my resources will be there. At certain point in time, I conducted this workshop, and it is still accessible on the YouTube. So that was the motivation to keep it virtually online so that it is accessible to everyone. And also you feel a sense of satisfaction that yes, you see, if you simply teach in class and if you come out, you'll forget everything. But if you create a digital content, you leave a footprint. So you leave a footprint, and tomorrow you also can go back and access it. Let's say tomorrow I'm called anywhere to any other place to conduct a workshop. Definitely, I will be seeing my videos that what I have taught and how I can do better. So that is something amazing which you can do with this particular software now. Okay. So let us begin. It's almost 6:10 and we are 10 people now. And you can see that on the last day we are only just 9 people. So 23 people registered, and out of 23 on the fag end, we are only 9. So 9 divided by 23 is close to, let's say, 45 to 50%, not even 50%. Let's say 45% people are there on the last day. So let's begin. So I'm sharing my screen. All of you just pay attention. So today is the last day. Yes, okay. And one more thing, certificate I will be giving you a week later, because I have a session in Delhi day after tomorrow. So and I'm preparing for that, and it's a very detailed session where I will be talking to research scholars in an online mode. So I'm preparing for that. So it will take some time for me to issue you certificates, and couple of you have asked for receipt. Now receipt I can't give it to everyone, because to say this, I don't have a receipt per se of this particular startup or data matic research solution, but I will be generating and giving it to a few scholars who had particularly mailed me. So please don't ask for receipts, everybody. Only 2-3 people who are associated with Mumbai, with certain universities in their place, and they're asking for, then I will definitely give it. Okay. So now today is the last day. Yes. Okay. And let me do a quick recap. Quick recap. Yes. Okay. So by the way, this is a textbook called Seminar. Yes, this is a seminar textbook. And yeah, I followed the tail of this particular textbook throughout this workshop. Yes, okay. So this is a book, and the language of the book is very simple. And here the authors have spoken about everything that is important for a researcher to 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 test their model, to perform to run their model, and to perform their analysis. So this is a wonderful book by Hare, Hult, Ringel, Sarsted, Danks, and Somyare. This is a wonderful book. You should read it. The language is also very simple. Yes, and the uh, uh, analysis is also pretty easier, and they have given their own analysis. And the people are asking me doubt even on WhatsApp that is this package foolproof? Yes, is this package is foolproof. And also you can use combination of packages. Now, normally when I do my analysis, I run combination of packages, and nothing harm in writing the statistic. Whenever you write your research paper, in the statistical part, you can mention that which software you have used it. And by the way, you can combine all the R packages, and you can do a critical analysis of the R packages and compare it with smart PLS phone, and you can write a very good paper which can be published in European Business Review A star, or for that matter Journal of Business Research, which accepts papers on particularly PLS SEM. So there is a good what you call as a topic which is there before you, which will be full of novelty, and you can write this paper, and you can find a journal, and you'll get exposed to a wider audience across the world. So definitely use R and produce some paper. And but you see again, there is a what I see when I'm using particularly PLS-SEM, I could see that there is a big methodological gap as far as usage of PLS-SEM is concerned. And there are a lot many papers which can be written on the methodological issues on PLS-SEM. So that is one amazing aspect which after conducting lot many workshops and myself using PLS-SEM, I can see that there is a good scope to contribute to the methodological researchers, particularly in the PLS-SEM approach. Yes, okay. So this is a wonderful book, and if you click here or to the left hand side, you'll see an introduction to SEM, and then overview of R&R Studio, the seminar package. Yes, again, it's a wonderful package capable of handling both the methods of SEM, CB-SEM as well as PLS-SEM. Then we saw how to evaluate the reflective constructs. Now, when I say reflective constructs, it is the construct that causes indicator. Yes, so when a construct causes the indicator, so that is a reflective measurement model. And here there are convergent validity issues and discriminant validity issues. By the way, the idea of the idea of SEM is applicable particularly to reflective constructs. Now, CB-SEM is particularly, if you use IBM Amos, you are basically dealing with all the reflective constructs. Yes, okay. So initially, SEM was designed to handle reflective constructs. But when you talk about formative construct, that is module number 5, PLS-SEM is father as far as handling of formative constructs are concerned, because PLS-SEM is nothing but it's a combination of principal component analysis and multiple regression. So it uses PCA and multiple regression. So again, PLS-SEM is very capable, very robust of handling formative measurement models. Yes, it's excellently designed to handle formative measurement constructs. So if you have formative measurement models, let's say you're working in the field of finance, economics, or for that matter, econometrics, then PLS-SEM is really a silver bullet to you. Then how to evaluate the structural model. Now, please pay attention. Now, yes. Now, when I say evaluation of formative measurement model, let me go back. So formative measurement model, there is something which is known as redundancy analysis. So whenever you have certain formative constructs in your measurement model, it is always advised that you need to have one global item, and you need to include that particular thing into your questionnaire. Now, somebody asked me, I think 1 or 2 days back, that should content validity of single item construct be established? Of course, 100%. Any item that you use in your research, it's content validity. Now, when I say content validity, it means, let's say you have measured one item. Is that one item measuring what you're intending to measure? So content validity has to do with the accuracy of that particular measure. So let's say if you have used one item, so that one item should suffice to measure the constant that you are intending to measure. So whenever you are having a formative measurement model, it is always better, it's advisable, and it's mandatory that you include one global item in your research, and later on and calculate the correlation or calculate the beta estimates of the multi-item constructs and the one item constructs. And if the one item, if the beta estimates is greater than 0.70, we say that convergent validity in formative measurement model is established. By the way, again, you have to see the VIF values. You can see the weights. Then if the weights are not significant, then see the loadings. There are mechanical steps that you need to follow. Yes, but hardly I come across that people use formative constructs. People, particularly in marketing, or for that matter, psychology, or let's say OB, HRM, they are more obsessed with the reflective model. Again, the beauty of formative model is that all the items in a formative construct, they have a certain degree of uniqueness. See, all the item in the formative construct, you'll find that they are unique in certain respects. So if you feel that you are designing a scale and where all the items are slightly different, they are not collinear to each other, then yes, you are actually going for a formative measurement model. Yes, okay. Then let's focus on the structural model. Again, structural model, before evaluating the structural model, you need to be sure about the measurement model. First, you need to check for convergent validity, discriminant validity. All these issues should be sorted. So when convergent validity, discriminant validity issue is sorted, then only you need to go and establish the structural validity of the model. When I say structural model, it is assessing the path relationship between the constructs. And again, structural model here, you need to check the VIF, that is variance inflation factor. VIF values, and VIF values preferably should be less than 5. And if it is less than 3, it is the best. So check the VIF values and check the R square. And after checking the R square, then also you need to go and establish the predictive validity of the model. Then here you see Q square. Then here you see PLS predict. You divide your sample into two, training sample and hold out sample. And then you can compute that RMSE and the MAE score. And then you compare your RMSE or MAE score with the linear model benchmark. So if your RMSE scores are producing lesser errors, you say that your model is a decent model, and you go with it. Yes. So structural model. So things are very clear. It's you, if you read any standard paper where PLS-SEM has been applied, so there are standard steps which people follow, and it is fixed. So you need to follow those steps in your research, and you need to build argument around all those steps, that what is your VF value, what is your Q square, what is your RMSE, what is your R square. Yes, and of late people are also talking about model fit indices. Now, again, it's very common in papers which are published in IMB Review. IMB Review is a journal by IIM Bangalore, and there, whenever you read papers where PLS-SEM has been used, they are talking about model fit indices. Though model fit indices is not a characteristic of PLS-SEM, but IMB Review has a very unique way of even writing. All the authors write about model fit indices. Yes, okay. So see the journal which you are targeting, and then accordingly you go ahead with it. Then yes, then the seventh topic that we saw is mediation analysis. Now, mediation analysis, again, we discussed in length what is mediation. So whenever you talk about mediation, you are exploring the latent construct, one new construct in the relationship of the two constructs. So a mediation analysis always explains the underlying process as to how a relationship is being caused. So mediation is also known as testing for indirect effects. Testing for indirect effects. So whenever you conceptualize a particular construct as a mediator in your model, you need to build a very strong argument as to why you feel that this mediator is important and why it needs to be studied. So mediation analysis. So whenever you are doing a mediation analysis, it is always advisable to check the significance of the indirect effect. So if the indirect effect is significant, we say mediation is there, and in the indirect effect is not significant, we say mediation is not there. Now, some literature also talk about full mediation and partial mediation. Full mediation and partial mediation. But of late, if you should only go and say that there is a mediation. Don't say that there is a partial mediation or full mediation. Simply say that there is a mediation. Then again, moderation analysis. Now, when I talk about moderation analysis, there are two kinds of moderator. One is a continuous moderator when there is a construct. Let's say there is a construct which is measured using a multi-item statements. So when a construct is a moderator, we call it a continuous moderator. And sometimes moderator is categorical in nature. So I think Somaya, she joined late, and yesterday she had a question about it. So when you talk about categorical moderator, so see, categorical moderator, you are checking structural paths differently for different groupings in the data set. Now, let's say whenever you float a survey, you ask people's gender. And now when you run a model, you are running model for both male and female, and you are saying that, okay, this is a model which is applicable for everybody. Now, this is a wrong approach. Now you should go and check whether the structural model that you have tested, is it same for female, or is it different for male? So you should check that whether the structural model, because what happens that the structural model may be very strong for males, but very weak for females. But when male data and female data come together, the effect gets nullified and you get an overall weak results. So it is always advisable that to check for multi-group analysis. But once you have used a particular demographic variable as controls, then don't go and check the multi-group analysis for that particular variable. It's always better to put the controls in your model, but particularly on the dependent variable, put the controls on the dependent variable, not on the mediator, not on the antecedents, or not on the independent variable. Put the controls on the dependent variable and check whether these control variables which are confounding, which usually confounds the relationship, it doesn't happen. Yes, okay. So when your moderator is categorical, we go for multi-group analysis. Multi-group analysis, nothing but you are checking structural model for two different genders or two different groups, and then you are commenting whether there is a significant difference or there is not a significant difference. Again, seminar package is beautiful, and again you can simply estimate PLS, estimate underscore PLS underscore MGA. You can simply do, and you can do the moderation analysis. Oh, sorry, multi-group analysis. Okay. Now, if you focus on this particular textbook, so this particular textbook is stopping up till moderation analysis. Up till moderation analysis. Now, today is the last day, sixth day of this particular workshop. So let us focus on the agenda. Yes, okay. And if you focus on the agenda, whatever has been promised to you has been delivered. Okay. Now here, if you focus that on the let's say again, we also talked about model comparison. We saw CV pattern, all those things. So today is day 6 and March 10, Sunday. So here we'll talk about advanced issues in PLS-SEM. So again, where we'll focus on unobserved heterogeneity, non-linear effects, and endogeneity. So today's session, that is from 6 to 9:30. By the way, I will not go till 9:30. We'll wind up by 9 or 9:15. When then we'll keep a group photo and we'll share our feedbacks. We can share our opinions, and we can also discuss that how we can collaborate in times to come and how we can write papers. And now somebody might be very good in analysis. Somebody might be very good in theory building. Somebody might be very good in literature review. Somebody might be very good in writing the discussion part. It's always better that 4 or 5 people collaborate. Now, again, there are rules of collaboration that whenever you collaborate, there has to be a discipline. You should decide that time frames and this should be respected. And you can have a virtual meet, and you can decide. So let's also explore possibility that can a collaboration happen in this small ecosystem, or let's say 20-23 people which are there, and how this collaboration can go ahead and a win-win situation can be created. We'll discuss in the last 15 minutes. Okay. So today we are going to talk about advanced issues in PLS-SEM. Now, I want all of you to pay attention. All of you to pay attention. Now, simply type PLS-SEM or let's say PLS-SEM.net. Now, there is one website, my friends, all of you. Kartike, is my screen visible to you? Kartike? Hello. Loveji, my screen
Yes,
is
sir, it is visible.
okay. Okay. Thank you. Thank you. Thank you. So simply type PLS-SEM.net. So there is one website called PLS-SEM website, the software for next generation of PLS. And if I go to this particular website, it is PLS-SEM.net. Okay. So this is the website. And again, the video will be there. You can access later on. So what I'll do, I'll just paste it for you so that people can access it. So this is the website where you find all the announcement by the developers of Smart PLS, that whatever new developments that happens, they just upload it here first. Okay. So this is a primer on partial least square structure equation modeling. By the way, there is a book also in this name. Third edition is the latest edition, which has been shared with you, and it is there in the folder. Just go and read it. It's food for thought, and this will help you in your research work. Yeah. Okay. And here, if you see, they have some online courses also, but they use Smart PLS 4. They will not teach you through R&R Studio, because R&R Studio is free source. They expect you to learn on their own. So on March 2nd and 3rd, they have an online course, and which is Foundation of PLS-SEM using Smart PLS 4. And again, June 13 to 14, they have online course. They conduct it on Zoom, like how I'm conducting. And it is on advanced topics of PLS-SEM. So today's session is on advanced topic of PLS-SEM. By the way, let me honestly make a confession before you. I'm not covering necessary condition analysis, and I'm not covering what you call as MyCom and so many other stuff, because see, I'm yet to explore all those things, and I feel that our studio, doing all those things in our studio, we can do it, but it will be very cumbersome. And I'll show you that when I will be doing endogeneity test. So you see how challenging it is to do everything in our studio. So NC, I think so Sonam was talking about that NC and all, and yeah, IPMA you can definitely do it. Yes, okay. So there are one or two topics which I'm not covering it, so don't mind it. But But whatever has been discussed in this class, it will definitely help you to publish in reputed journals, provided you have a very good model. And one more thing, I didn't speak too much on the model building on the very first day. Please remember that whenever you build a model, my friends, all of you just pay attention. It's very important that whenever you build a model, see to it that all your constructs are not answered by one particular person. Please remember this, because this is the biggest disadvantage. You are measuring all your constructs from one single person. No. Now take example, the higher order construct, or higher model that we tested it. Now again, it is based on my data. So it is always advisable that when you are measuring performance, don't measure performance from the individual. See, there are scales available, and there is no harm in measuring performance from individual perspective. But if you are measuring performance, see, it is okay you ask somebody psych. It is okay if you ask somebody citizenship behavior or organizational identification. But when it comes to, let's say, performance, go and ask the respondent's boss as to how was his or her performance. So it is always better to measure certain variable from different parties rather than measuring all the variables from one party. So again, that's the disadvantage of and when you measure variables from different people, then you definitely can exploit the true meaning of PLS-SEM, that PLS-SEM is a causal predictive approach to SEM. See, when you collect all data from one person, then you can't make prediction. You can only say that there is an association or there is some relation between the variable. So when you collect data from multi parties and then fit it to model, and then you want to interpret, then yes, that is a very nice way of saying that yes, A is impacting B, and B is impacting C. So and if you read about PLS-SEM, they say it's a causal predictive approach to SEM. So causal predictive approach to SEM, you can definitely exploit its full feature if your data is of that particular quality. Sometimes we have a data of poor quality, collected all the variables from one person, and that always becomes a disadvantage. So please focus on that particular part. Whenever you have 4 or 5 constructs in your model, try to measure all the constructs, or some of the constructs from different persons about that particular person. Let's say it's psycap. Now psycap can be measured. Psycap can be measured by the respondent itself, or you can ask the colleague of 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 the respondent as to how is his or his how is her or his psycap level. So you can, now a colleague has spent too much of time with you, let's say 15-20 years, or let's say 5-6 years, and the colleague will be better able to understand that how is your psycap level. So you can give a psycap questionnaire to the colleague of the respondent and then match it in the Excel, because that matching part has to be done very systematically. Yes, so it's always advisable to collect data from multiple parties and then conceptualize into a model. Then you are able to write better, and people take your research very seriously. Cross sectional research of late thoda sa criticism mein hai, and that's why if you all top notch journals, they are focusing on mixed methods, or for that matter 2 studies, 3 studies, or one experimental study, one cross sectional study, or one longitudinal study, and combination of all those things. Okay. uh, Now again, here if you focus, so this is the latest book. So if anybody has access to this particular book, please share with me, and maybe in your library or maybe wherever it is. So, or if you find some in times to come, some PDF version and all, please share with me. I'm yet to access this book. I've written to one of the labs. See, I'm not part of any organization now. So I've written to one of my friend, and he said whenever he'll be getting it, he will be xeroxing and sending it to me. Okay, so this is the latest book on PLS-SEM. Here you will get all NCA, IPMA, and so many other stuff, and model comparison, and unobserved heterogeneity in your models. That everything you'll find in this particular book. So again, they have uploaded it. Then this is not important for us. Again, yeah. So this is a new open access book. This book is freely available in Google Scholar. Simply type seminar, you'll get this book. And this book was released in 2021, just 3 years back. Okay. So yeah. Okay. And this is the third edition. Third edition, it's available, and I've shared with you the third edition. And if you go down, you'll find lot many things. Just go and click it. Then 2022 international conference, and they have lot many books. They have organized conferences on PLS-SEM, and whatever conference papers were there which were similar in nature, they have compiled that also. So by the way, if you focus on the reading material, I've shared lot many new stuffs with you. You should go and read it. And here you see so many things other than PLSM course and training and software and all, so many things. And here there is something called as PLS-SEM books. So these are some of the books. Then downloads, yes, they have not many download options. So again, book files, advanced issues, and PLS-SEM in R, go and download and read it. Okay. And then we have courses. Just explore this particular software. Courses will be taken by these are heavily cited authors, and they're highly paid authors, Hare, Ringel, and Sarsted. You should definitely explore. And then there is a smart PLS software. So here you can get the smart PLS software. You can buy it for 1 month, and you can access it. And then there are literatures available, recommended readings, special issues, and just see this. So which are the recommended readings? You can simply go and see. So let's say if you're understanding PLS-SEM, so these are some of the recommended readings that you should definitely go it. And somebody was asking about multi-group analysis. So again, here there is a multi-group analysis using smart PLS step-by-step guidelines. So they're reading materials also. So don't forget to explore all these things. And lastly, there is UTAT model. I think Afrin was working on UTAT model. So again, they have CB-SEM compared with PLS-SEM. They have compared CB-SEM with PLS-SEM, and they've given certain analysis. Okay. So all these things are there. So now let's proceed. So this was just a flashback of what we did, because this is the last day and I have to bring everybody on the same page. Okay. So today's now friends, all of you just pay attention that today we'll focus on three important things. Okay. So first is your again, see when you're, let me use the whiteboard, and then let me give a small brief to you that what is today's agenda and what we'll be talking about, what will be covered today. Okay. So I'll share this Microsoft whiteboard in the uh, uh, in your reading material as a whiteboard. You can reflect whatever was discussed in the class, and let's take a blank. Okay. So so friends, just pay attention. So today we'll check about uh, uh, result robustness checks. Result robustness checks. Okay. Now please note that whenever you are using PLS-SEM, or for that matter any SEM, first step is to validate the measurement model, that everything is fine, reliability, validity. So measurement model, whenever you run a measurement model, actually you say that everything is reliable and valid. So the reliability and validity is addressed in the measurement model. Okay. And when you talk about structural model, particularly in PLS-SEM, we first focus on VIF, then R square. Yes. Then we talk about Q square. Then we talk about PLS predict. Now, once your measurement model is over, structural model is over, we need to go for result robustness checks. And by the way, this result robustness checks are applicable to structural model. You can also call it as structural model robustness checks or model robustness checks. Now, see, again, now just pay attention that whenever you are using PLS-SEM, yes, PLS-SEM, please note that it combines PCA, principal component analysis technique, and multiple regression. And people who are well versed with regression, they will understand that there are a lot many assumptions in regressions that needs to be checked. Yes, that your residuals should be normally distributed. Now, whenever you run a regression and people have a doubt that my data is not normally distributed, see, regression never says that your data should be normally distributed. No, regression never says that. Regression says that your error term, let's say you regress y on x and then you get some y hat. So the difference between the y hat and y means the difference between the observed variable and the predicted variable. So that is your residuals. So one of the assumptions of regression is that the error term associated, the residuals should be normally distributed. Then it talks about homoscedasticity, heteroscedasticity, and so many other things are there. I don't remember all those things, but there are so many assumptions and riders to regression. So if those assumptions are satisfied, then only you can interpret your results in a very systematic way. If the assumptions are not satisfied, then the parameters that you have got, it will be misleading. So that's why people who are from hardcore statistics field, They always check the assumptions and then they go for all this parametric approach to statistics, particularly regression and all. Yes, okay. So if I have to say that PLS-SEM is nothing but an extension of regression. It's an extension of regression. Yes. So now there are certain issues that we need to answer whenever we use regression. So first thing is that see, now whenever we run a model, let's say when we are testing a model, we say that A leads to B. So we always hypothesize that, or we consciously, knowingly or unknowingly, we say that all the variables are linearly associated to each other. So we only say that, let's say if SIC, if you talk about the earlier model, influencer data model, so we say self influencer connect is related to purchase intention. So if you are able to connect yourself with the influencer, you will develop purchase intention. So whatever the influencer is endorsing or whatever product is advertising. So if you like an influencer, you will buy that particular product. That's why you see Amitabh Bachchan, Shah Rukh Khan, and all this Bollywood celebrities. They are paid heavily to advertise a particular product. Why? Because people developed a connect with them, and studies are showing that if you develop connection with your influencer, you are bound to engage into purchase intention. So there is a direct relation. So now you are here, you are saying that SIC is related to purchase intention. Now you are saying that it's a linear relationship. Yes. See, all the models, there is an underlying thought process that all models are linear. So there is linearity assumption. We feel that the relationship between two variables are linear. What if the relationship between two variables are not linear? They are non-linear or curvilinear, whatever it may be. See, even when we go for correlation test, Carl Pearson R, we say no, that two variables are positive, are linear and positively related or negatively related. So there also we are taking we have an assumption that two variables will be related in a linear way, either in a positive way or in a negative way, but there is a linear assumptions. What if your variable comes to be non-linear? So there is first result robustness checks that we need to report non-linearity effects in the model. We need to check. Now we have uh, uh, gone ahead and said that two variables are related to each other and there is linear. So now go and prove that in real life or in real data it is linear. So there are tests available for assessing the non-linearity effects. So this is the first result robustness checks or structural model robustness checks. Second is your unobserved heterogeneity. Second is your unobserved heterogeneity. Heterogeneity. Now, what is unobserved heterogeneity, my friends? See, now there are certain observed heterogeneity. See, when you ask somebody's gender, if you ask somebody's gender, you can divide your data into male and female data. If you ask somebody's designation, trainee, junior, or senior, again, you know that people are in three categories. Somebody are trainee, somebody are junior, and somebody are senior. So you can divide the Excel file into trainee, junior, and senior. Now there are certain known sources of heterogeneity, like gender, or somebody's caste, somebody's educational background, or somebody's designation. These are known sources of heterogeneity. Now, when you collect data, you know the known source of heterogeneity, but apart from that, you feel that all data is homogeneous. You feel that, or you make a guess that all my data is homogeneous. But there could be certain clusters in the data. There could be certain groupings in the data which is apart from the known sources of heterogeneity. Please note this. Let's say you have a data of 400. Yes. Now in those 400 data, there could be certain groupings which could be based on psychometrics. Now see, people differ in age, gender, and all those things. People differ in demographics, but psychometrically also people differ. See, let's say now you will feel that two females are same, but no, two females are not same. Their thought process and their psychometer in their mental makeup, they will be different. Now you may assume that all trainees in the data set are alike. No, some trainees might not be like the other person. So one is the known source of heterogeneity, and there is one unknown sources of heterogeneity. There will be some clusters in your data set. in which the structural model will be different. Now see, what is the idea of multi-group analysis? The idea of multi-group analysis, now you are extending to unobserved sources of heterogeneity. Now in multi-group analysis, you know the grouping, men, female, or men or let's say male and female. Now you run a separate model for male and you run a separate model for female, and then you check whether there is a difference in the path relationship or not by simple means of t-test. Okay. Now, similarly, if there are unobserved groupings in the data, how to identify those groupings and have a structural model for those particular data. So there is unobserved heterogeneity in the data. Yes, okay. And now your third is your endogeneity assessment. Now these are all advanced things. Endogeneity assessment. Now again, all of you, my friends, just pay attention. What is endogeneity assessment? Endogeneity assessment. Now, friends, now see, let's say take example of let me take example of this particular model. Let's say LMX leads to OI and OI leads to OC. And this is a simple mediation model. Okay. Now, if I have to write a regression equation, how will I write? Now, which is my dependent variable? My dependent variable, my OCB is my dependent variable. So Y will be my OCB. Yes. And beta naught, this is some constant term. Yes. Plus my beta 1 will be the coefficient of LMX, plus my beta 2 will be the coefficients of OI, plus there will be some error term. Yes. Now let's say you have conceptualized a model. Now, do you think OCB in an organization is because only of OI and LMX? Now, see, whenever we create a model, we identify some variables, let's say 4 or 5 variables. What if you have not taken that variable, which is very important in the model? Yes. So sometimes because of missing variables in the model, now anybody in this class, can you identify in this particular model LMX OI OCB relationship? OCB, that is helping behavior or pro-organizational behavior, is it because of OI and LMX? Can anybody guess what is that one thing that is missing in this model? Hello, anybody? See, OCB, again, it is based on personal factor. I'll give an example that from my experience, I can tell you that if I see my characteristic or if I see my mental makeup or psychometrics, if somebody is, let's say, if I can give an example, it will make a lot of sense to you that I will definitely go extra mile to help a person. I will definitely go an extra mile to help a person. Let's say if I'm traveling in a train and if a woman comes, so nobody will get up, I get up and give that woman a seat. Again, if an old person comes, senior citizen comes, I get up and give that person a seat. So not only it's giving to seat and all, but in various ways, I demonstrate OCBI, that is organizational citizenship behavior towards individual. So now when somebody is engaging into OCB, it's simply not because of LMX or it's simply not because of OI, it's also because of personality. So now in this model, LMX, OI, OCB, my friends, there is one variable, personality, which is missing. That's why you'll never get 100% R square in social science, because you miss certain variables. So personality is missing. So do you think this LMX, OI, OCB in this particular model, will I be explaining something very important? No. Now, sometimes when you miss a particular construct in the model, yes, it can so happen that the error terms in the independent variable, let's say that there is let's say this is my independent variable OI. Yes, okay. And this variable might be correlated with the error term of the dependent variable. See, this error that you see, this is error of OCB, means that part of OCB which is not explained by LMX and OI. What is error? Friends, what is error? Yeah, OCB not explained by LMX and OI. Definitely, personality is a very important construct, and you have just missed it. Now, it can so happen that the error term, or let's say the error term of the independent variable might be correlated with the error term of the dependent variable. Yes. So when two error terms correlate with each other, there is bound to be an endogeneity issue. There is bound to be an endogeneity issue. So endogeneity becomes a concern for a variety of reasons. But one concern is that your predicted variable error term will be correlated with the error term of the dependent variable. Yes, and this may give you a distorted uh, 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 parameters about the model estimation. Yes, so it is always advisable, because anyway, see, PLS-SEM is nothing but it's a regression technique. So whenever after your structural model robustness checks, you need to account for nonlinearity effects, you need to account for unobserved heterogeneity, and you need to account for endogeneity assessment. But having said that, most of the papers that you see in A category, or for that matter, even in A star category or B category or C category, they stop up till PLS predict, that is establishing the predictive validity of the model. Most of the people. But there might be certain reviewers, particularly in top-notch journals, A or A star, who are well versed with this PLS-SEM methodology, and they might doubt that there will be certain checks which you need to apply in order to talk, or in order to comment on the credibility of your findings. So, certain reviewers might ask you to report for result robustness checks. Then in that case, after establishing the predictive validity of the model, you need to check for these three effects: nonlinearity, unobserved heterogeneity, and endogeneity. By the way, go back to my first class. I have been telling it again and again that PLS-SEM is a very robust approach to SEM in its present form, because the science of PLS-SEM is not stable, or not stable in the sense, stable is a wrong word to say, it's not fixed now. So people are coming with new innovations in PLS-SEM. That's why PLS-SEM is becoming more dynamic. In CB-SEM, you see, now I'll tell you, see, first of all, I'm not criticizing that CB-SEM is bad and PLS-SEM is good. But now CB-SEM, everything is settled now. In CB-SEM, everything is settled. Model fit ho gaya, structural model ho gaya, theek hai, ho gaya. But PLS-SEM now, the knowledge in PLS-SEM is not settled. Now people are coming with new advances. And this makes the use of PLS-SEM even more, what you call as, detailed and dynamic, and PLS, I would say it's in a state of a flux. Flux means it is changing. It is changing. Now, of late, people are talking about that, yes, people should go and report the result robustness checks. So that's why PLS-SEM is more dynamic, and in terms of popularity, yes, now PLS-SEM is more popular. Forget about focus on the smart PLS4. They have included CB-SEM into it. And yesterday I saw the post of James Gaskin in the LinkedIn. He said that the day smart PLS4 takes care of MGA, multi-group analysis in CB-SEM, again it will put IBM Amos behind. Okay, so it was just some write-up. I was just reading his LinkedIn post. So that is how it happens, my friends. Okay, so yes. Okay, are we on the same page? Hello. Can anybody respond? Hello. Let me talk to you first. Hello. Are we on the same page?
Yes, sir.
Okay, so today we are going to see result robustness checks. It is also called as structural robustness checks. And we are going to focus on three important things. First is assessing non-linearity effects, because we always have an assumption that all the constructs in our model are related in a linear way. Yes, okay. Second thing is that we will account for unobserved heterogeneity. Now there are known sources of heterogeneity where we run a multi-group analysis, and in your data set there could be some unknown sources of heterogeneity. It could be because of psychometrics, or it could be because of any other reason. You need to account for that. And third is endogeneity assessment, where the error term in the predicted variable will be related to the error term in the endogenous variable, and because of which your findings will be not up to the mark. So by the way, endogeneity is itself is a very big topic. So if you talk about people who have done, by the way, all this endogeneity assessment these are the topics in econometrics. So people who are well versed in econometric sciences, they speak length about endogeneity, that what are the sources of endogeneity. Now there are multiple sources of endogeneity, but here for this particular session, we are talking about just because of missing variable, some variables or some constructs that you have not included in the model, which is causing certain error in your overall results. So how to account for endogeneity? That's why it is always advisable to do a thorough literature review and identify every construct which has an impact on the dependent variable. So please, all those people who are in the research stage or PhD stage, simply don't take constructs on the basis of your own intuition or insight. Do a thorough literature review, do a systematic literature review, or bibliometric analysis, whatever some new answers are coming. Just see which are the variables which are impacting your dependent variable, and try to model all those variables into your model. And just see that first of all, a researcher should make effort to include every constructs in the model, so that endogeneity doesn't pop up. But having said that, endogeneity is simply not because of missing variable. It is also because of measurement issues. It's also because of so many other stuff. So it's altogether a very different domain. And again, that is not my expertise, econometrics, to talk about which are the sources of heterogeneity. Yes, okay. But endogeneity could be because of multiple reasons, and one strong reason is missing or omitted variables in your model. Okay. So now friends, okay. So here, if I go to this particular R syntax file, so here, friends, in the R syntax file which I've uploaded here, I've uploaded this model robustness checks for you. So syntax I've uploaded here. So people who are practicing, they can download it from here. Simply download it, and you can bring it in the R Studio.
So you can share the screen.
Achha, screen is not there. Okay. Yes. So what I'm saying that, so this is the folder that has been shared with you. So that is R syntax, and in R syntax, this is the new file that I have uploaded. You just need to download it and run it in order to account for result robustness checks. Okay. But before I proceed with result robustness checks, I want to share with you all a very important paper. And this is the paper. Again, an old paper. Now, any paper which dates back 5 years, people say it is old. But sometimes old is gold. And by the way, many new papers have come. And if you simply go to let's say ResearchGate is there, and simply type here structural. This is ResearchGate. Let me check if any new papers are there. Structural. And by the way, you should regularly follow PLS-SEM net. So there you'll get a lot of reportings. Structural model robustness checks in PLS-SEM. So there will be many free source in see here you see. Okay, robustness checks in PLS-SEM. A review of recent practices and recommendation for future application research. And this is a recent paper published in JBR. Again, JBR is an A category paper. It requires a lot of rigor to publish in. And you see, again, I'm saying, no, in JBR, you'll find a lot of paper where people talk about methodological extensions in PLS-SEM. JBR, Journal of Business Research. You should definitely read papers on JBR particularly. Yeah? Okay. And if your intention is to publish very good papers in next 5 years in your PhD program, you should focus most of your analysis in reading A star and A category paper. So when I was of your times, when I was like most of your research scholars, when I was of your in your time, just 5 years back, and I had very little understanding about modeling and all those things and all. So at that time, nobody advised me, nobody guided me that I should read only A star and A paper. I'll tell you on a very lighter note, that this session is being recorded. Let it be recorded, nothing wrong. Let it be on YouTube. People learn from my folly also. So initially, when I started my research, I started reading UGC Care Journal. Because Uh, so I started reading UGC CARE journal and all those stupid journals and all. They are not stupid in the sense, but I started my analysis that way. So, but still today, till today, I feel that if I go back, I can do a much better research. If time goes back, and I will do a much better research. And again, by the way, there is a global consensus that when you do a PhD, actually you are learning a research. But get some advice from good people and attend some good workshops from quality people, and you'll find that you're a better fitting. So all people who are doing your PhD research and all, and who will be taking on the research forward, try to follow few journals. So Journal of Consumer Research, Journal of Business Research. So here you can see that, see, okay, now I'm very old, I'm using a 2019 paper. So here you can see robustness checks in PLS-SEM, a review of recent practices and recommendation for future applications in business research. Please get this paper, and if you get this paper in your let's say in your library, please share it with me also. Put it in the. So for the last decade, scholars have employed PLS-SEM. Here you see they're talking about robustness checks, and see, yeah. So to get access to this
Sir,
paper, or
we can request for full text. Sometimes the authors are kind enough to share the paper.
yeah. So let me request from here. Okay, request is sent. Send. Okay. Request is sent, and they will perhaps they will send. And if you go down again, Sonam, advanced marketing and analytics using PLS-SEM. So by the way, ResearchGate is a wonderful place where you can do lot many recent. Again you see November 2023 paper again by Hair. See, Hair is there. The moment you see Hair, so introduction to PLS-SEM. So lot many things are there. But okay, fine. Having said all those things, let us come to this particular thing. So I'm taking this particular paper, structural model robustness checks in PLS-SEM. Now, why I'm taking this paper? Because this paper has explained things in a very simplified manner. And I personally feel that when we are learning econometrics and structural model, things need to be simplified. Because if we don't understand in a simple way, we won't be able to explain it in a logical way. Okay. So again, paper written by Sarsted. See his name you'll find everywhere. Sarsted Ringel. And Sarsted Ringel, again, these are the developers of Smart PLS. Okay. So let me simply go through it, and then we'll talk about nonlinearity effects. So here they talk about that PLS-SEM has become a standard tool for analyzing interrelationship between variables. So along with the recent surge in the methods used, research has contributed several complementary methods for assessing the robustness of PLS-SEM results. So let me mark this. Robustness of, let me mark this. Let us go slow today. Uh, Results of robustness PLS-SEM. So here, this article illustrates the use of recent advances in PLS-SEM designed to ensure structural model result robustness. So when you talk about result robustness, it is particularly related to structural model, not with measurement model. This is what I stated at the outset. And here, in terms of nonlinear effects, we'll check for nonlinear effects, endogeneity. This is because of omitted variables, and unobserved heterogeneity, the brother of MGA. MGA is for known heterogeneity. Unobserved heterogeneity, you are not knowing the variances which are there in your model. Okay. So here, if you talk about, so let's talk about first nonlinearity effects. Now, let me go through this paper so that everybody is on the same page, and let us go slow. Now we always think that two constructs are related in a linear way. What if there is non-linearity? So now you need to go and report that yes, two variables are non-linear. Okay, means two variables are linear, non-linear. You need to go and report it. Now you can't course correct it. Now see, when I was working in my PhD thesis, I've done all this model robustness checks in my PhD thesis. So if two variables are non-linear, can you do anything to make it a linear? The answer is no. The answer is no. See, once you have collected a data and it turns out to be that two constructs are related to each other and there is non-linearity effects. So there is a non-linear relationship. You simply can't go and fix it and say, now I'm going to make it linear. No, you simply need to report it. If there is non-linear effects, just report it. If there is endogeneity issue, report it. Yes. And write in the limitation section that there is endogeneity, some missing variables and all those things. In the limitation section, you can write it. Huh? Okay. And lastly, if there are unobserved sources of heterogeneity, just talk about it and report the results separately. So it's a wonderful paper and simple paper. So yes, okay. So here they talk about that everybody is skipping this model robustness checks. Yes, okay. And here, let me touch this. Huh? So when estimating path models, researchers usually assume that the relationship between constructs are linear by nature. While linear relationships generally approximate relations found in reality, well, this is not necessarily always the case. Always two variables will not be linear. Nevertheless, studies using PLS-SEM have only rarely considered nonlinear effects. See, most of the studies, they are saying that most of the studies are not talking about these nonlinear effects. And they're talking about all those things. And let's see how they have addressed the nonlinear issues. Huh? So let me go through it. See here, it is in this paragraph. Huh? And this paper recently I've uploaded this for you. And I will strongly request the paper which I saw on LinkedIn, JBR, please go and read that also. So when the relationship between two constructs is nonlinear, the size of the effect between the two constructs not only depends on the magnitude of the change in the exogenous construct, but also in its values. So what does it say? The size of the effect between two constructs. See, the effect between the two constructs, it says it not only depends upon the magnitude, but also in its value. To put it simply, it is saying that if you say that this is my beta, or let's say this is my beta and this is significant, but it tells you nothing about that how two variables will be related. Now please remember this. I think Kiran asked me this doubt in the first session or second session somewhere. I think Kiran did raise about it. Let's say again a very simple example. In our case, let's say my independent variable is, let's say, LMX, and my dependent variable, it's, let's say, organizational identification. By the way, I'm going to take this model, which is part of my research. So OI I will write here and LMX I will write here. So this is my x-axis and this is my y-axis. So as the relationship quality improves, OI will improve. But after a certain point in time, this will have this particular shape. And let's say you have a beta, let's say LMX and OI, the beta is, let's say, 0.534. So it tells you nothing. It only tells that, okay, two are related. But it doesn't tell you at what point in time OI will peak and it will come down. And same with performance. If you improve the quality of leadership, performance increases, but later on it will come down. So please understand all those things. And real life, this happens. So here they are talking about, to test whether or not relationships are nonlinear, researchers can run Ramses. Yes, this is the test that will be running in R. So far, this test was in Smart PLS-3, this was not there. Please remember. Now, Smart PLS-4 is very advanced. They have incorporated many things, but in Smart PLS-3, this test was not there, and this test was there only in R. So to test nonlinearity effect, there is one test which is known as Ramses regression equation specification error test, reset test. So to implement the test in PLS-SEM context, researchers first need to estimate the model and use the resulting construct scores as input for reset with standard software such as Stata and SPSS. So in Stata SPSS, people used to do, not in Smart PLS-3. And this test was there in R. By the way, in SPSS, it is there. You can do it very easily. So this test considers quadratic effects, which are the most common, and the cubic effects by default. So there is one quadratic effect and there is a cubic effect. So normally when you are accounting for nonlinearity effects, you should check for quadratic effect. So if quadratic effect is there, or let's say if the quadratic effect turns out to be significant, then you say that yes, nonlinearity is there. And if nonlinearity is there, simply report it. Don't do anything. Yes, simply report it. You can't do anything. Okay. So yes. So now we can do all these things. So as this implementation, all those things, blah blah blah. Let's come to this. Okay. Hope we are on the same page. Now my friends, I'm sure that many of you will not be practicing because this is the fag end, and you'll get the video. Don't worry about it. So now what I want now, if you remember, I shared with you the D data file, which is part of my research work. And now let's import this D data file. So yes, Kiran, go ahead. Yes.
So, sir, if I want to check non-linearity of a particular variable, or if I want to find out if the performance of suppose team is like on the first day it was less, then like this, the way you have just drawn the bell curve graph. So how should I collect the data?
See, Kiran, it's always better, no? It's an interesting question, Kiran. First of all, let me admit this. Now, Kiran, if you want to track a team's performance over the period of time, then here you require time series data, Kiran.
Okay.
And but yes, see, first of all, linearity is not for a variable; it is between two variables. So whenever you talk about linearity, it has to between it. You check it between two variables. If there is the association non-linear, and to answer you, when you are observing somebody's performance over a period of time, you really require a time series data. So you need to record on the first day what was the performance, second day what was the performance. And by the way, bringing a time series element into a cross-sectional study, Kiran, it will be an interesting research. It will be an interesting research. And my humble advice to all of you, if possible, please learn time series data. Please learn. So Kiran, to answer you, it will be a time series data if you are measuring everyday performance and then averaging it out. Or you can do that way also, Kiran, that measure performance by giving task. See, try to embed an experimental study in your research. But again, it is your call. And measure people performance at let's say 2-3 times or 4-5 times, and then average it out. Then create an average, and then you can use it in your modeling as a cross-sectional data. No problem with that, Kiran.
Sir, and one more question.
Yeah.
If what if the variables are different at every point?
Like how?
Because as the team interacts over a period of time, different kind of behavior will be or attitudes will be generated. So with that, team performance will also change, is what I'm
So let's say
theoretically.
if T1 is interacting with T2, or let's say T3 or T4. Okay. So their attitude will change every now and then, no? Okay.
Yes,
Then
because
you should have an attitude sheet. Attitude sheet. Let's say these are team members 1, 2, 3, 4, 5. And let's say interaction with T2, T3, T4, and here you should give attitude, hate, like, respect, whatever it may be. You should create some matrix, Kiran. Create some matrix.
Okay, sir. I
And
understand.
then try to find it out. But you see again, no, if I can add you, Kiran, it's very interesting thing that if I can add, again, I'll go to my first session. I said I'm not a great fan of SEM, either PLS-SEM or CBSEM. I'm not a great fan, because here what you are doing, you are capturing the constructs and finding their relationship. That's it. Yes.
Right.
And but there are many things which are happening with your sample on a daily basis, or on a, let's say you're talking about interaction between teams, you are not capturing only that. Let's say we are saying job satisfaction. Okay. Job satisfaction depends upon what? Salary. Job satisfaction depends upon what? Co-workers. How is your co-workers? Job satisfaction depends upon your leader. How is the quality of the leader? Job satisfaction depends upon your future in the organization, or future prospects. Many things. But here we are not focusing on so many other things which are happening within it. Let's say, but again, when you account for all this little nuances, Kiran, little nuances, interaction and all, then some novelty you try to bring into your research. By
Right.
the way, people know what are the see, every person know what are the antecedents to job satisfaction. People know what are the antecedents to job satisfaction. लोग ये job satisfaction ये खराब हुआ तो turnover intention पे क्या खराब फर्क पड़ेगा. Just think, no, are we happy with our organization or not? आपको खुद ही सवाल मिल जाएगा whether you are happy with your organization or not. And if you are unhappy with what specific element. Okay, that's a different thing. But create some metrics and try to capture their emotions, behavior, or performance, and then see if this matrix you can correlate with some and come out with some theory in that. Yes. Okay.
Okay, sir. Thank you.
Okay. But unfortunately, no, we all are following one branch of research. We are not capturing data from multiple sources. But it's a good thing. Try to be more innovative and try to capture what people are feeling and what people are thinking and all. That is more important.
Can
Okay.
we do the analysis of time series in this software?
Yes. See, again, by the way, Kiran, by the way, my future, I'm planning to conduct a workshop on time series. So you can see these are time series, ARIMA model and all those things. So I'm learning time series. In future, you can expect.
ARIMA and ARDL, both are, sir, very significant and very good for time series analysis.
Yeah, that's why. So this is a wonderful, Kiran. In fact, bringing a time series component in organizational issues, or for that matter, any topic, it's a wonderful thing. So in future, you can expect that I will conduct a workshop on time series, which
Sir,
is
ARDL is useful for short term as well as for long term analysis in time series.
yeah. Loveji, you work on time series data.
See, yes, sir. Little bit I have worked, and my PhD is on time series data, sir. But
By
I
the
have.
way, Loveji, see, in this open workshop, and this is being recorded, I would suggest you,
Hmm.
please learn time series for next 20-25 days. Suggest
sir.
me a convenient date. I will schedule a workshop and I'll do a thorough marketing for you. Yes.
Okay, sir.
Okay. Please
Definitely.
approach me, and let it be SPSS, or for that matter, let it be Minitab, any software that you're comfortable.
Sir,
Not
I have worked on R and Stata both, sir.
So by the way, I have also Stata in my machine. You'll find somewhere I have a Stata also. This is Stata. This is the pirated one, by the way.
Even I do have from IIT, sir.
So from IIT Roorkee, I got it. One of my
Even
friends.
me also, sir, from IIT Roorkee.
So Loveji, my humble request, take 30 days time, 40 days time, master in Stata, and just perform one workshop. We'll take care of you. Don't worry.
Okay,
Okay.
sir.
And by the way, it's open. If some of you can feel that, yes, you can confidently speak for 5-6 days. See, some mistake here and there happens, and let us be very open. We all are learning. Yes, some mistake happens. But if you can address a audience confidently, you are most welcome. Please write it to me. My mobile number is there with you. Please reach out to me. I'll be happy to host you. It will be my pleasure that through you, knowledge will be disseminated, and we can have some economics around it. Okay, nothing wrong in having an economics around it. Okay, yes. Now, friends, hope Kiran, I answered you. Let me proceed now. Yes. Okay.
Yes, sir.
So now I will import the D data file. So D data file you can see here only, because syntax here only see in the D data file you can hear it, because yes. So import data set, from here only I'm importing. So it's slightly taking a time, and yeah, it's imported. So after import, what is the step that you should do, all my friends? After import, what you should do? Attach the file. So if you attach the file, you can extract whatever you want. Yes, you can extract whatever you want. Yes, okay. Now, now again here I'm using all this seminar package. I'm using seminar package. So let me here write 2 more steps: install dot packages, and write sem in R. Should give me pop-up here. Sem in R, and next is library, LIBRARY, sem in here it is. Now I'll just invoke this. I'll invoke this because a seminar is not there. I need to invoke it. So yes, you should always install the packages. Now again, now I'm assessing non-linearity effects. See what I'll do. First I will run the model. All of you just pay attention. All of you just pay attention. First I'll follow those 5 steps: create measurement model, create structural model, estimate the model, bootstrap the model, summarize the model. 5 steps. I think Sonam was asking 5 steps. 5 steps. Yes, okay. So let me create the measurement model. And what is this model, my friends? This is the same model that you see before you, LMX OY OCB. So this is the model I'm testing, my friends. This particular model. Silence. 1 second. My baby is like running in a walker. So this model, my friends, I'm testing LMX OY OCB. OY is the mediator in the relationship of LMX and OCB. So here let me write the measurement model. So here line number 14. Again, you know the syntax. Again, it's a very simple syntax. Yes, LMX, it's composite, multi-item. Now here you can see 2, 3, 4, 5, 6, 7. Yes, 2, 3, 4, 5, 6, 7. So in fact, earlier when I was testing this particular model, so 1 and 2, 1 variable and 5 variable. This is 1 and 5. Here should be 5. It had poor loading, so I dropped it. So now let's say there is no issue of poor loading. Let's for timing assume there is no instance of poor loading. And OY 1 to 5, and here also see in OCB you can see 2, 3 missing. Yesterday you remember in LMX there were 1 or 2 items, on OCB there were 1 or 2 items which had poor loading. So I've removed all those things. And let me run this. Okay, everything is fine. Let's run the structural model. Line number 21 to 24. Let me run this. Okay. And then estimate the model. This is estimate the model. Okay. And what is it telling? See, there are error terms. It is saying this column is not matching. Can you see this? This column is not matching. When I say column is not matching, it means here 2, 3, 5, I need to check this D data. So what is LMX 2, 3, 5? See, it happens actually. So 2, 3, let me check actually. So 2, 3, 4, 6, 7. Yes, okay, combined LMX multi items. So, okay. Let it be. Let's do structural model. Summarize the model. Object PLS model not found. Actually, it's not reading this. It's not reading this. So again, let me run it. I will change it. Don't worry. I'll change it. Sometimes I get overconfident, so it creates problem for me. Okay, path model is okay. And if I run this, so it is showing that all local measurement model is simple vector. It is saying that it must be simple vector. So instead of 2, 3, 5, 6, I can write LMX. I can simply write LMX also. Let me check. Let me do a trial error. Please bear with me. And simply let's say LMX2 or LMX3, LMX4, LMX6 and LMX7. Now let me run this, and if things improve, or let me check. If it doesn't improve, I'll find some shortcut for it. And run the path, and let me run this. Object, what is it telling? PLS model found error, bootstrap model and boot 100. Object CL not found. Just a second. Erase. Just hold on. Control Z here. Control Z. Control Z. Control Z. Control Z. Control Y. Library seminar. Just give me some second. Let me add 1, 2, 3 here also. Then I think there will be no problem. 2, 3, 4, 5, 6. Yeah. Here I think so. There is one extra. This. Yeah. Okay. There was an extra. This one. Should it be there? No, it should be there. Otherwise, there will be question mark. Just wait. Something is missing, and it creates problem of such kind. It creates problem of such kind. So some small step here and there. One mistake. The problem is with the matching of the data. I've just understood the data is not matching it. So here you can see. Let me read it. So can't subset columns with all loc non-item measurement model. Subscript all local measurement model must be simple vector, not a matrix. Run to see what the error occurred. Ran. Aha. Earlier it was giving, and suddenly there is a problem. Just hold on. Just give me some time. Measurement model constructs LMX multi items. LMX C2, 3, 4, 6, 7 and composite OI 1 to 5. Composite OCB C3. It should run here. See, sometimes it creates problem of such sort. Constructs. Okay, summarize the model is running. No, it's not. It's saying PLS model not find. It means a difficulty with the measurement model itself. Can anybody find out what's the difficulty in the measurement model? Why is it not accepting?
Sir, just to check the data, sir. We can make it as LMX1, LMX2 like that. Because
let me check. Yes. LMX. This is LMX4 5. We can write LMX also. No harm with it. But let me use all. If I can use all, if I can solve the problem. 4. Let me use that. Let me try later on. What Felix sir is saying, no, we'll try later on. And here I'll include 2, 3, 4. Let's say 1, 2, and 3. 1, 2, 3, 4, 5, 6. 6 is missing. So 6. 1, 2, 3, 4, 5, 6, 7, 8. So let me run this. Okay, and path model OCB relationship to OCB from LMX to OI and from OI to LMX. This is also okay. Oh God, come out. See. So there was some problem in this column, sir. Okay. So now when you get all 19 observations are valid, Better this problem came before you. So you can understand that how much effort you need to make to get the data. Let me shift the pane this side, window pane this side, sessions, view and panes, console on the right. And let me minimize this. So I'm not going to interpret all this alpha and all those things. And let me bootstrap the model. Yes. And summary the model. So here you can see this is the direct path. So LMX to OI, it is significant. LMX to OCB again significant, and OI to OCB, all the direct paths are significant. Yes, okay. And check the loadings. Reflective construct, you should check the loadings. So all loadings are above. See, there is a problem with this loading, 0.514. It's less than 0.708. Yes, check the AV and all. AV and all. Can I check the AV? Just a second. Let me check the AV also. I didn't check it, no. You see, there is a AV is okay, fine. AV is this is. See, there is a problem in AV with OCB, but let it be. Let's assume that everything is fine because we want to learn nonlinearity effects. I'm not redoing it because it will take a lot of effort and some mistake it will happen. Now, friends, all of you just pay attention. All of you pay attention. Now, this is the till bootstrap the model. This is the basic step. We all know how to bootstrap the model and get the analysis. Now, what we have to do, we have to extract the construct score. So if you focus on line number 34, we will extract the construct score. So how to extract the construct score? See, this is. So I'll simply copy this and paste here, and just okay. And here, if you see, there is constructs. No, just a second. Construct score I want. So dollar, and if I go here, where is the construct scores? This is the construct scores. This is standardized scores, huh? See, you have measured LMX by 1, 2, 3, 4, and this is the latent construct scores. See, now why I'm extracting this construct score? Please understand this, huh? So I have extracted this construct score, my friends, and after this, I'm going to just extract. See, if I want to extract LMX, how should I do? You remember in data matrix when we were learning data frame, and in data frame, let's say we wanted to extract only one column. So how did we do it? You always use the box bracket. Remember, box. Whenever you use a box bracket. So what I'm doing is that now I'm using this con estimates construct scores. Yes, okay. So this is the construct score I've extracted, and then let me run this. Just a second. Can you see line number 38? So this is cont or estimates construct scores. So this is or rather you can put it this way. ये निकाल करके आप can remove this and you can put this. Control C and Control V. Let me run this. Let me run this. I've changed, slightly modified it. Yes, and if I simply type LMXQ, I'm getting the first column. Yes, see, first column is 0.250 and this is 0.250. So let's extract the individual construct scores. Now why? See, whenever you are accounting for non-linearity effects, you actually see whether the quadratic effect is significant or not. So when I say quadratic effect, you square the construct score with itself. Now just pay attention. I think this is a very old file that I'm using it. So let me copy and paste here. So let me extract the second column. And similarly, I'm extracting the third column. And I'm creating a vector, my friends. So 3 vectors I'm creating: LMXQ, OID, and OCBO. So I've changed the name. You know why? Because already this OCB LMX are there, no? So I've just changed the name. And let me run this. First, second, third. Picture is fine. Now, if I type LMXQ, I'll get LMXQ. If I type OID, I'll get OID. If I type OCBO, I'll get OCBO. So I've extracted the columns from the construct score and stored it. So the LMXQ, I'll get the construct score of LMX. Similarly for organizational identification and similarly for OCBO. Now see, I'm creating a quadratic term, my friends. I'm creating a quadratic term. I'll explain once again with the model. Don't worry. So what I'm doing, I'll multiply LMX by LMX. So this multiply, I'll multiply LMX by LMX and stored it in a quadratic term. So let me run this. Similarly, I will create a quadratic term multiplying OID with OID and create this. And now what I'll do, I'll run the regression with the quadratic term. Okay, see, please understand, please understand. Okay, just a second. Where is this? Now, this should not go bouncer to all of you. What is non-linearity of X? Now, if you pay attention, this is our model, LMX, OI, and OCB. This is our model. And if you focus in this model, this is your independent variable. LMX is your independent variable, and this is your first DV, and this is your second DV. So there are two dependent variable and one independent variable. So now I want to check whether non-linearity exists in this relationship in OI. So what I'll do, I'll keep OI as my dependent variable. Yes, okay. And then I will use that linear. I will run a linear regression. So what I'll do is that, let's say if this is y is my OI, and then beta naught plus I will use let's say beta 1 will be my LMX, and plus beta 2 will be my this quadratic term. The quadratic term is like quad LMX that I've created. Yes, getting? So see what I'll do. See, I've created a quadratic term. I extracted the construct scores. See how you create a quadratic term. See, the quadratic term, yes, is nothing but LMX multiply by LMX. So just multiply LMX with LMX. So now if I come to this, here if you focus, again I'm repeating. First I extracted the construct score and stored it in individual vectors. Now here I'm creating a quadratic term. So I'm naming a new vector, LMX into LMX, quad OID, OID into OID, quad OCBO, OCBO into OCBO. So now run the regression with the quadratic term. Okay. And significant quadratic term indicates the presence of non-linearity effects. This I have written for my understanding so that I don't forget. Now here all of you pay attention, friends. This LM is linear model. OID is my dependent variable. So OID depends upon what? LMX and this particular quadratic LMX. Okay. So let me show you this. Let me show you this. Run it. Close the bracket. Just a second. Control Z. Control Z. Here I need to come. Bracket close. Yes. Control it. Can you see this equation, my friends, all of you? Can you see this equation? This OID is my dependent variable. LMXQ is my construct score. Yes, construct score that I've extracted. OID is also construct score. And this quad LMX is the quadratic term. Okay. And simply I'm adding summary at the beginning. Yes, summary, and simply closing this. And if I press enter, now here you see, now just interpret the results. So this is the coefficients. Here you see the quadratic term. This is significant. So when quadratic term is significant, we say that non-linearity is there. Actually, this should come out to be non-significant. So you extract the construct score and run an individual regression on every dependent variable. As simple as this. Extract the construct score for LMX, for organizational identification, and for OCB, and run independent regression. Now, similarly, I'll run a regression keeping OCBO as my dependent variable, and I will check for LMX. Earlier I checked for OID, no? Now I'm going to check non-linearity for this particular relationship, whether in LMX OCB non-linearity exists or not. So here I will write the equation y OCB is equal to beta naught, some constant term, plus beta 1. Beta 1 will be my LMX, and plus beta 2 will be my quad LMX. So as I check for OI, similarly I'll check for OCB, and similarly I'll check for OI and OCB. Similarly, here I will check for this also. So here equation will become what? Y is equal to OCB is equal to beta naught plus beta 1 OI plus beta 2 quad of OI. So quadratic term is nothing but creating an interaction term, like moderation. You remember in moderation, you created an interaction term. So when I say quadratic, actually you are creating a interaction term. You are creating an interaction term, my friends. Just bear this in mind. Okay. So here now let me check for OCB, whether OCB and LMX there is a non-linearity present or not. Yes. Can anybody interpret the result for me? Felix, can you interpret the result?
Sir, yes, sir. Here, it is not quad term. The quadratic term is not significant. Hence, non-linearity doesn't exist between.
Very good, very good. So if your quadratic term becomes significant, it means there is a non-linearity effect. And if it is not significant, you see that non-linearity effect is absent. And similarly, check for OID. So if I check for OID again, here there is no quadratic term. So it means LMX and OI. LMX and OI. By the way, LMX is a very, if you see LMX relationship quality is never still. Today you will be in the good books of leader. It's not guaranteed that 5 years down the line you will be in the good books of a leader. You will abuse your boss maybe. It can so happen. So LMX and OI, definitely you'll see some flux or you'll see some change happening here and there. Okay, but for other construct, it's okay, it's fine. So this is how you check the. Now again, now see, first of all, if you read that paper by Sarsted, what did it say? That there is a test called Ramsey's regression equation specification error test, reset test. Now see, why did we ran for this quadratic effect? Actually, this is coming from this. Here you see. As this implementation of the reset test relies on construct score estimated from linear effect. See, the construct score that you extracted, it came from a linear effect. See, you extracted a construct score, no, for LMXQ, OID, and OCB. So it came from a linear effect. So therefore, researchers should also check whether the specification of nonlinear effect yields a significant results. So now you have extracted a score from a linear effect model, and straight away, if you apply test reset, it's saying no, don't do this. First, check individually. Individually create the quadratic term, run a regression separately, and just check whether the quadratic term is significant or not. To consider, for example, a quadratic effect in PLS-SEM, researchers need to consider a polynomial model and add a quadratic term. So first, what you should do, you should test the quadratic effect. Polynomial model means taking the dependent variable, taking the independent variable, and creating the quadratic term of the independent variable. First, check the significance of the quadratic term. This quadratic term is similar to an interaction term which comprises the exogenous construct in the interaction with itself, like moderation. So if the interaction term effect is significant and positive or negative, the strength of the exogenous construct effects increases in the exogenous construct at higher values. What is it telling? If the interaction term effect is significant and positive or negative. So if the interaction term is significant means the non-linearity is there. So the strength of the exogenous constructs effect increases in the exogenous construct higher values. So if there is linearity, so if the strength of your exogenous construct effect increases, means if the beta value of the exogenous construct increases, so that is going to impact your exogenous construct at higher values. So this is what they are saying it. Conversely, a non-significant interaction term offers evidence of non-linear effect robustness. If it is non-significant, if the interaction term is non-significant, it means there is an evidence that linear effect is robust. So if it is significant, it means non-linearity is there. And if it is not significant, you say that linear wise, the result is robust. Yes, okay. So please understand this. So ideally, everybody would like that this effect should be not significant. So if the quadratic effect is significant, it means there is a linear effect. And if it is not significant like here and here, we say that linearity is not a concern and it's robust. Okay. Now, again, I'm skipping all this thing. This is for standardized beta. And Let's apply this line, Ramsey's regression equation specification error test. Actually, this test they have spoken about here. Ramsey's regression equation. See this line, Ramsey's regression equation specification error test. The authors are talking about it. So now this Ramsey's regression equation specification error test, which is known as reset. Okay. Now this is there in this package called LM test. Now there is a package called LM test. So we need to install that package. Now in my machine, this package is already installed. So what I'll do, I'll simply invoke the library 66. Okay. Forget about this warning. This warning has no meaning. Now here, see, now what is the function? Reset test. So there is a function called reset test. So if I simply type reset, see reset test. And can you see? It is saying that Ramsey's reset test for functional form. Okay. So if you simply tick here and put a question mark, you'll get the syntax how to write. So here you see it's a syntax. Reset test, write the formula. Formula means first I will check for OID and LMX relationship. OID depends upon LMX. And power is 2 raised to 3. Means it will check the, see, 2 stands for quadratic effect, 3 stands for cubic effect. So this test actually by default checks both the quadratic effect and cubic effect. But cubic effect we don't want. We want, see, linearity is only judged by the quadratic effect. But by default, this test will give you quadratic and cubic effect. And type is like just keep regressor. Yes, okay. So now I'll run this line number 70. If I run line number 70, so this test is significant. It means linearity is there. In this relationship, OID and LMX, linearity is there. What is the null hypothesis? You have written. Null hypothesis is there is linearity in the model. And this is there is but this is non-linear in the model. So this is rejected. There is no linearity in the model. There is no linearity in the model. So this p value is, if it is small, we reject the null hypothesis. What is the null hypothesis? That there is no linearity in the model. This is reject. Actually, there is a, so no, this was right. Sorry.
Yes, sir. Linearity is correct, sir. That is the
linearity is correct. Linearity is correct. So this p value is small. So we reject null and we say there is non-linearity. There is non-linearity in the model. So this is one. And secondly, check for OCB LMXQ. Here p value is not significant. So there is non-linearity. Okay. So there is a linearity. Here there is a linearity. Model is linear. And similarly for this, again, this p value is greater than 0.05. So we say this is linear. So these two models are linear. And this was also supported. This was also supported in the significance of the quadratic term. So quadratic term supported it and reset test supported it. So two tests are supporting that. Your LMX OCB relationship and OI OCB relationships, there is non-linearity. But there is a presence of linearity in the LMX and OID. Okay. And now how to report? How to report? You should see reporting style. You should follow this. See how to report in your research papers. You need to report in this way, my friends. See, this is the way. Assessment of non-linearity effect. So first create the interaction term and check it on the dependent variable. So by the way, they have a model. They have taken this particular model, ATT, IPTO, trust and some COM. So here what you will do, first you will check the interaction term. Yes, on the dependent variable. And you write the coefficient and write the p value. See here you focus all the p value are greater than 0.5. It means linearity effect, the effect is linear. Non-linearity effects are not there. If p value is greater than 0.05, it means non-linearity effects are not there. Yes. And then they have applied this Ramsey's reset. And they have reported the f value and some that term. Let us see, is it the same? So what they have reported? They have reported this value. You have to report this. 3 is what? This will be your degrees of freedom, I think so. They have reported this 3,349. 3, no, they have 3,349. What is it? This, and this is 0.58. See what they have reported, friends. 3,3494. What is it? So you can report this value. Okay. Report this value and then report the p value. Just report this value and the p value. Here they have reported this one. By the way, in my book, in my PhD thesis, what I have reported, let me check. By the way, let me open my PhD thesis. What I have done, let me check. So even I have reported this advanced robustness checks. I have gone in my thesis. See here I have reported. See, again I have reported this f value. F is what here? I'm confused slightly. Just let me check what is f. So is this f? So f is 2,262. No. I think that they're talking about degrees of freedom. Yes. So this f is degrees of freedom. Sorry. So here you will take 2, comma, what you will write? 262. 262. By the way, 268 by sample size. And this is this value. This is this value.
Sir. To
This is
df1 comma df2, sir.
this is
F parenthesis df1 comma df2. That is 2,95.
2,90. Yes. You're correct. This was for larger sample size, and this is 99. No, you're correct. So this is degrees of freedom. So here 2,95. Felix, very good, Felix. Keep it up. God bless. By the Felix is a very intelligent kind of a research scholar, huh? And he's really doing very good.
You have taught me everything, sir. I
No.
owe everything to you, sir.
Sometimes I forget how it is reporting is done, because reporting is important. So this is the first degree of freedom. This is the second degree of freedom, and this is this value. This is this value, and then you are reporting the p value. So here, if you focus on my
Sir, value 2.2428 is what? Which value is?
so this is this reset value, sir. This value, sir. Sir, actually, no, this is on a larger data, sir. And this is on a smaller data. So you should write f 2,95 equal to 6.353 and then report the p value. So by the way, whenever you report it, see the standard paper, how standard papers are reporting it. Accordingly, do it. Similarly, for second, you will report 2,95. You will equal to you'll write this value and write the p value. I hope you got the idea of nonlinearity effects. Yes. So if the quadratic term is significant, nonlinearity is there. If p value is significant, nonlinearity is there. Just bear this in mind. Okay. Hope this much is clear, all of you. Hello. Any doubt? Or bouncer?
Not 100% bouncer, sir, but we have to do the revision again, sir.
Video will be there. Just see it and
Yes, sir.
let's do it. Okay. So now it's
I think representing the values according to the need of the analysis and interpreting it will be little complex, I think.
no, sir. Just follow this paper, sir. Nothing will be complex, sir. You follow the tail of this particular paper, sir. You should always take one base paper, sir. See here, read it. They have given, sir. If you focus on this line, no, sir. Just focus on the linearity one. They have explained everything, sir. In this one para, they have explained everything, sir. Yes, okay.
Okay, sir.
So if quadratic term is significant, it means non-linearity is there. If p value is significant, it means non-linearity is there. So people would like if quadratic term is not significant and p value is greater than 0.05. Then you will like, okay, yeah. But even if non-linearity comes, to just report it. Just report it that non-linearity is there in the model. Then people will understand, okay, LMX and OY, you at certain point in time, if you try to increase LMX, OY is going to come down. Aisa ho sakta hai. So just report it. So this is result robustness. You have given the structural model results. Now again you are reporting the result robustness. Okay, now it's 7:47. Let's take a break of 15 minutes. We'll be back by 8.2, or let's say we'll back by 8.2 or 8.3. Yes, okay. So let's take a break. Let's take a break. Let's take a break. Okay, let's take a break. After the break, I'll take your doubt and then I'll proceed ahead. Okay. Chalo, let's meet very soon. Hello. We are back. Everybody's there? Everybody's there? Okay. So should we start? Aditya, Felix, Dipali, Shilpa, Kiran, Lavji, Sonam, Gandhali, Vanita. Should we start?
Yes.
Okay.
Yes, sir.
Yes, sir.
Okay, so today is the last day and we are at the last leg of the workshop. We are learning a very interesting topic, model robustness checks, which particularly applies to the structural model results, not to the measurement model results. And just now we completed we assessed for non-linearity effects. Now, non-linearity is very simple. Please don't confuse yourself. You only have to create one quadratic term, means multiply the independent variable by itself, extract the construct scores of the independent variable and multiply with itself and create a quadratic term the way you create in moderation. Yes, and if the quadratic term is significant, we say that non-linearity effect is there. Ideally it should be not significant to comment that yes, linearity is there and non-linearity is absent. People would like that non-linearity should not be there, but you can't change it. Simply go and report it whether linearity is there or not there. Simply just report it, and people who are expert, they will understand how to interpret the effect of two variables when non-linearity is there. People will understand it. Don't worry about that. Okay. Now in result robustness checks, there is not much of strategy which you can use to fix your result. Please don't try to do that. Just simply report it, and simply reporting will suffice. Okay. Now let's focus on another thing, which is known as checking for unobserved heterogeneity. Yes, unobserved heterogeneity. Okay. Now again, if I can take this particular uh, uh, Microsoft whiteboard. Now please remember heterogeneity in data. Heterogeneity in data. Now just bear this in mind. Heterogeneity could be on account of two reasons. First reason is there are known sources of heterogeneity. There are known sources of heterogeneity. Yeah, okay. So when I say known sources of heterogeneity, these are all your demographic variables. Yes, all your demographic variables like gender, designation, okay, or let's say caste, or say education, bachelor's degree, master's degree. Yes. So when you know the sources of heterogeneity, my friends, you simply perform multi-group analysis. That's it. Okay. And the another source of heterogeneity is unobserved sources of heterogeneity. It's nothing but MG only, but MGA you know it, unobserved you don't know it. So there is unobserved sources of heterogeneity. And this could be because of psychometric differences. This could be because of psychometric differences. Now, when I say psychometric differences, it means people's thought pattern. People's thought pattern. Yes. Normally, we assume that all male are same, all female are same. No, there could be further subgroups within the larger group. Okay. And it will be wrong to say that all your data is homogeneous. Okay. Okay. So now what we will do, again, now we will change the package. Now we will change the package. By the way, there are a couple of good papers that I've uploaded for you. And this is a very tedious topic, a robust topic. I don't claim expertise into it, but I will try to give full justice to this particular topic and make you understand in a better way, so that you all do this particular analysis. Yes. Okay. So here, if I can go and show you this particular file. So here, reading material. So I've uploaded the reading material. Yes. Okay. And here, if you focus this paper by a lot of paper by 16, 17. Let me take this paper, 2015 paper or 16 paper. See this paper. See this paper. Identifying and treating unobserved heterogeneity with Phimix PLS part 1 method. So if you remember in if you see smart PLS software, there is one procedure called finite mixture. So Phimix is a technique to identify unobserved heterogeneity in your data set. Again, this paper is written by all Hare, Sarsted, Ringel, all known people. And again, So they have given various techniques and methods how to identify the various unobserved heterogeneity sources in the data set. So this is one paper, you should go and read it. And again, testing measurement invariance of composite using partial least square. Again, it's another paper. Again, it talks about MyCom. MyCom again is a tab in Smart PLS-4. Yes, okay. And next is this paper, partial least square structure equation. One of this is a general paper that I've shared. And yeah, okay. So again, if you talk about here, if you go uh, in the research gate itself, just talk about unobserved heterogeneity. You'll find latest paper, unobserved heterogeneity in PLS-SEM. If you simply type, you'll get some result. Yes. Treating unobserved heterogeneity in PLS-SEM, a multi-method approach. So multi-method approach, it is given by Sarstedt Ringel. You can see this paper, download it also. Then robustness checks, definitely we have talked about it, and identifying unobserved heterogeneity in mobile wallet adoption, a FIMIX PLS approach for user segmentation. Again, November 2022 paper. So such paper you should just identify whenever you are identifying. See, whenever you want to find the unobserved source of heterogeneity in the data set, just see what are the latest methods that are doing it. Yes. Now again, I'm not using FIMIX and MICOM and all those things. I'm going to take one data set, particularly D data, and we will see unobserved source of heterogeneity using rebus segmentation. So by the way, there is one more package in R which is known as PLS-PM, PLS-PM package. Yes, if you simply type PLS-PM package in Google, so here you will get the PLS-PM package, and unfortunately you don't get the Vignet is there. Sorry, Vignet is there. Let me check the Vignets. So yeah, in Vignet they have given the full book itself. They have given the full book itself, and if I click here, so here somewhere they talk about this PA, but again, yeah, they have not talked about it. Running PLS-PM, and no, they have not talked about here because this Vignet is not up to date. Yes, okay. By the way, again, if you see this Gaston Sanchez, actually it is he who gave this PLS-PM package. So Gaston Sanchez, it is his website, Gaston Sanchez. And here, if you go to his website, he has given this entire book, Partial Least Square Path Modeling with R. So if I this book is freely downloadable. So Gaston Sanchez website, this book is freely downloadable. And here you can see detecting classes with rebus PLS. So this is response-based unit segmentation, rebus PLS. So here, let me click here, and this is detecting classes within rebus. So within your existing data, there are certain classes. So there are certain segments. Yes. So that segment is identified using a rebus PLS. That is response-based unit segmentation. Okay. So it talks about diversity in data. Now we feel that our data is homogeneous, but actually it is not homogeneous. There will be certain diversity in the data set, particularly when you collect large data. And let's say Kiran is working on team level data, so there will be divergence within the team. But when you are taking measuring constructs from 500, 600 people, so there is bound to be certain heterogeneity in the sample itself, and that is hidden. That's why it is known as unobserved sources of heterogeneity. So how to account for diversity in the data? So these are unobserved classes. Again, that same unobserved classes, when you talk about it, is same that addressing unobserved heterogeneity. Yes. So here it talks about, see, perhaps the most naive and simplest approach. Let me read it. Perhaps the most naive and simplest approach to tackle unobserved heterogeneity consists of a sequential two-step procedure. Just read it. And they're talking about in PLS-PM, the most known approaches for detecting unobserved classes are FIMIX PLS. Yes. And reverse PLS by. So there are two methods, FIMIX PLS and reverse PLS. So this FIMIX PLS, it is there in Smart PLS, and reverse PLS, it is there in your R environment. Okay. So it is response-based unit segmentation. So reverse approaches. So here you see so many values and all, so many values. Okay. And they have given case study. Just go and interpret it. Okay. But now again, see, please remember, my friends, there are 3 packages. One is seminar, second is CSEM, third is PLS-PM. So the algorithm for writing PLS-PM is given here, or not algorithm, the syntax. The syntax slightly changes. If you ask my opinion, the easiest package, simplest package is PLS-PM. After that, seminar package. After that, trickiest is CSEM. Simplest package is CSEM, PLS-PM. Very simple. In 4-5 steps, you get the output. But you know, a couple of years back, when I was doing my PhD thesis, I relied on PLS-PM. Yes, okay. But PLS-PM was thrown out of CRAN. CRAN is like where all the packages are uploaded, and to come on CRAN is a very big thing. Yes. So this PLS-PM package, somewhere it was developed in 2013 and 14, but when I was doing PhD, it was thrown out. So somebody asked me, "Arey, you are using a package which is not there on CRAN, so people will question you." I said, yes, it's a valid doubt. People will question that you are using a package which is not there on CRAN, so you got it from GitHub, and then you somehow you manage it. But fortunately now PLS-PM is again back on CRAN. See, now why is a package removed from CRAN? Now maybe again it's hypothetical. I don't know the exact reason, but what I anticipate is that there are certain queries and there are certain conditions which are supposed to be made by every package. So there was certain criticism associated with PLS-PM package, perhaps because of which it was removed from the CRAN. And later on, the authors went ahead and addressed it, and that's why again it is brought on CRAN. Yes, okay. So to come on CRAN, all the conditions and all the stipulation has to be satisfied. Why I call PLS-PM package as simplest? You know why? Because it gives you only PLS-PM algorithm. And if you talk about CSEM, there is something known as consistent PLS. And even in Smart PLS-3, if you remember Smart PLS-3, I have not checked the interface of Smart PLS-4 very much. But in Smart PLS-3, there were 2 tabs. One was for PLS algorithm and another was for consistent PLS. So let's say if all your indicators are reflective, then you should go for consistent PLS. If any of your indicators, or let's say if some of your constructs are formative, then you should go for PLS algorithm. So there was a big divide and debate over that, when to use PLS algorithm and when to use consistent PLS. But when you use PLS-PM, this package, it gives you only PLS-PM algorithm. Means partial least square path modeling algorithm. It doesn't talk about consistent PLS. Okay, so consistent PLS, it is there in CSEM. That's why you remember yesterday I was talking about disattenuate. If you make it true, then it will give you consistent PLS output. And if you keep dot disattenuate equal to false, it will give you a PLS-PM output. So there, all those things are there. All those things are there. Yes, okay. So this is a very beautiful package. 4-5 steps, you get everything. Huh? So now see, again, I'm not teaching you Fimix, but definitely we will see segments in our data set using Rebus package. Now, what I have done, my friends, we focus on line number 81. Again, this is, I've imported the ddata file, attached ddata. Again, this is the step that we have done. No, need not do it because there are multiple sources I have cut, copied, and created my. By the way, this all that you see before you, it's written by me. Okay, based on my data. So yeah, now we have to install line number 86. By the way, this package is already installed in my machine. You simply need to run line number 86. But if you're practicing with me, you need to first go with line number 85. Then wait for some time and then invoke line number 86. Yes. Now don't worry on this red line. It's just a warning. Don't get, now some people get confused when they see warning. Oh my, I'm not able to run it. No, don't. It's just a warning. Forget it. See how to specify the model. Now see, this is the mediation model LMX OI OCB. Now I'll simply, in short, I'll teach you the syntax. By the way, you can use multiple packages to perform your analysis, but you have to come up with a very valid argument. Now, friends, all of you just pay attention. Now, let me write this. Let's say LMX OI OCB. Yes, LMX OI and OCB. Friends, pay attention. And this is the model. LMX is connecting to OI and OI is connecting to OCB. This is the model. Now, all of you just pay attention, friends. Yes. Now, is there an arrow from LMX to LMX? No, there is no arrow from LMX to LMX, so you should write 0. Is there an arrow from LMX to OY? Yes, it is there, so you should write 1. Then is there an arrow from LMX to OCB? Yes, LMX to OCB, there is an arrow, you should write 1. Now again, is there an arrow from OY to LMX? No, OY, it's a recursive, non-recursive model. No, OY to LMX doesn't go. Then here you should write 0. Is there an arrow from OY to OY? No, 0. How can there be an arrow from OY to OY? No. Then is there an arrow from OY to OCB? Yes, OY to OCB, you can see this arrow. So there is 1. Then OCB to LMX, no arrow. OCB to Y, no arrow. And this is no arrow. Now friends, just pay attention. So can you see this? Here, LMX is a vector. I have combined it with 3 zeros. 3 zeros means this way you should write. When you are writing, means when you are creating path. See, every package will have its own way of writing the path relationship. Okay. So when you are writing, how will write the vector? LMX is equal to C 0 0 0. Then OI you'll write it C 1 0 0. Then OCB, how will you write? C 1 1 0. So this is how you define the path. Again, this I have not created. Gaston Sanchez has said if you are using PLS-SEM package, you have to write it this way. If you are using CSEM, you have to create structural model, then measurement model. If you are using Seminar, again you have to write in their way. So every package will ask you to report in its own style. You can't change it. This is rule, it is fixed. If you change it, it will show you error. So don't change it. Every package will have its own requirement. So now let me run this. LMX OI, Reddit, OI, OCB, OI, OCB, and this is, let's R bind it. And here you can write column names, col names. Let me check. Aega kya ye? Col names, path model. Let me just typing something. I want to check something. Equal to row names, path model. Yes, and if I simply type path model, that I'm getting. Yes, see this matrix I'm getting. By the way, when you're creating this matrix, no, please remember, my friends, when you're creating this matrix, no, this diagonal should always be 0. It should be a Boolean matrix. That is what they have reported. Boolean. They have reported somewhere. Huh? This diagonal should be 0 and above also should be 0. Sab upar 0 aana chahiye, 1 means sab niche aana chahiye. This is the condition. That's why they write it a matrix form. Okay. So let me, this command I have not written here. Let me write it. I'm very long back. I'm using this package after a very long time. By the way, I've used this package in my PhD. Whole names. Let me write it so that in future, if I'm taking workshop, I should not remember it. Equal to, I should not forget it. Row names, and this is path model. Okay. So yeah, and we are just selecting this and simply write path model and Control S. By the way, I'll upload this one. This renew one I'll upload for this. Run. Yes, I'm getting this. So this is the matrix that I created in the Microsoft whiteboard. Now, can you plot the model, inner model? Yes, let me plot. Can you plot the inner model? Run. Figure margin is too large. Okay. Yes. Can you see? Hello. By the way, you can color this. Huh? You can color this. So there is LMX to OI, OI to OCB, and LMX to OCB. Can you see the path model? Gandhali ji, can you see the path model? Hello?
Yes, sir.
Yes, sir. Yes, sir. Get it.
Okay. Hope all are there with me, flowing with the flow. By the way, this syntax is yours. Go and practice. Please go and practice. And there are n number of sources by which you can learn R, PLS-SEM in R. Very simple. It's not a rocket science. By the way, this is a mechanical step. I have created nothing. I have simply borrowed from the textbook and just written it. Yes. Okay. So path model. Okay. This is the inner plot. And now see, now we have created the path. No. Now let's provide data to the model. So 24 to 30. 24 to 30, when I say this is your LMX. Then 19 to 20 will be my OI. And 11 to 18 will be my OCB. You need to provide the data in the Excel sheet. Huh? This is the data in the Excel sheet. So if you focus here, so 24, just count. 24th item will be LMX. This will be 24, 24, 20. Keep the cursor here. This is 23. See, this is 23. And what I've written? 23, 24, 25, 26, 27, 28, 29. So this is 23 to 29. Simply keep the cursor, you'll get the number 23. And now what I've written? So this will show me an error later on. So let me keep it 23. Because this is an old file that I'm using it. So this is just a second. This starts from 23 and this starts from 29. 23 to 29. So 23 to this will become, you have to supply the data, means supply the data to the construct. And then they check OI. OI is from where to where? OI. OI is here. OI, just keep the cursor here. OI is from 18 to 22. OI is from 18 to 22. So this I need to change it. Otherwise it will throw me error. And you will never understand why this error is there. Yes. And lastly, OCB. OCB from where to where? So this is D data. OCB. Let's check OCB is from where to where. So this is 10 to 17. This is 10 to 17. So let me keep it 10 to 17. 10 to 17. Just supply the construct data. That's it. And now let's run it. What is it telling? Warning message. Achha, it's a warning message. Leave it. Then all my constructs are reflective. For reflective A, if it is formative, then make it B. Let me run this. Warning message again. Let me check. If it doesn't run, there will be problem. Setting row table name deprecated. My goodness. Okay, let it be. Let me summarize the model. Yes, Don't get frightened by all this. Sometimes it scares you. Then run ABC. Simply run ABC. ABC. You're getting the output C. You're getting the output. You're getting the output C in PLS-SEM. By the way, see what is it telling? Number of cases 99, latent variables 3, manifest variable 20, standardized data, false, path, and all those things. And by the way, this is LMX is exogenous, OI and OCB are endogenous. This is 7 item, 5 item, 8 item, and all my constructs are reflective. Yes, okay. And see this block unidimensionality. This is Cronbach alpha. This is DG row. This is not Dijkstra-Ansler row. This is only a one form of reliability. And this first eigenvalue should be greater than 3. Should be greater than 3, and this should be greater than this should be less than 1. This should be this should be less than 1, and this should be greater than 3. So if this is the case, then yes, conversion validity is established. By the way, Cronbach alpha, and these are the loadings. See the loadings. You can compare the loadings. Sonam, it will be the same, exactly same. See, the LMX1 loading is problematic. LMX5 is problematic. You should delete it. Yes, and here see OCB. This is problematic. This is problematic, and this is problematic. Okay, and here you can see the AV values. The AV of OCB is problematic. See, even in seminar and CSEM, there was some problem here. CSEM, there was no problem, but here there is a problem. OV is less. This is goodness of fit. And here you can find the correlation of the constructs. Means LMX has very good relation with OI. Means LMX impacts OI and LMX impacts OCB. Yes, okay. And OI and OCB has C, 70. Correlation is very good. Means if you want somebody to engage into citizenship behavior, you should make them identify with the organization. Now, how can you make people identify with the organization? By creating good managerial policies. You will be a very bad boss if you deny casual leave to your employees. This is what my understanding is. Okay. By the way, have you seen all HRs? All HRs, they have a constipation phase. I have seen all HRs in so many HRs in real world. They always have a constipation phase. Constipation means they always will be serious. There will be never happiness on their face. And HR is there to deny your right only. On a lighter note, this don't take it as a universal science, but majority of HRs you will find they are firefighters, and sometimes people say that even if there is no fire, they put fire and they try to douse it because how they condition it. On a lighter note, by the way, this is written in this book called K. Aswathapa by HRM by K. Aswathapa. These are not my saying. It's written in the book. I'm just sharing it. Okay. So yeah, okay. So model is run. Now here you can bootstrap the model, my friends. By the way, if you simply type PLS-PM, no question mark, you'll get all the hint as to what you should write inside. Here you can bootstrap the model. The estimate model over. See, sorry, bootstrap the model here. So here you can write 10,000 bootstrap. But now I'm going for 100. So let's bootstrap the model. Okay, run it. Let's bootstrap the model. So when this says setting row names or table is deprecated, means there is some problem with the screen size. Now summary boot estimate the model. So this is summarize the model. You're getting confidence interval. Huh? When you bootstrap the model and summarize it, you get confidence interval. Confidence interval where you can accept and reject the hypothesis. See, LMX and OY significant, LMX OCB significant, and OI OCB it is significant. In fact, we are doing PLS-PM analysis, PLS-SEM analysis using PLS-PM package. It's very simple. The easiest package is PLS-PM, my friends. Easiest. Slightly tricky, seminar. Trickiest, CSEM. By the way, there is one more package, SEM-PLS. I have not seen that package, and it's not that very popular. Just try to explore SEM-PLS. Even this is a package for PLS-SEM. Okay. Now again, I've written dropping the item, all those things and all. Okay. So let me drop this item. There are some problems, let's say, in dropping the item in. Can I skip this step? Or simply, if I boot estimate this, well, let me run this. Something is happening. Run this. Run this. So let's say I deleted some of the item. Just focus. I deleted some of the item here. Huh? Just assume I've deleted some of the item, lower loading and all. And now I again bootstrapped it. So you can delete the item and rerun the model. Where loadings are lesser, you should delete the item and rerun the model. And again bootstrap it and summarize the model. You're getting it. And yeah, now friends, all of you just pay attention. All of you just pay attention. Now, see, first of all, the very big question before is how many clusters are there in the model? There are a lot of confusion around it. Now pay attention. My data is how much? 99. Now, if you focus, my friends, there is one software called G-Power software. I'll show you. This is a G-Power software. And people use it for estimating the sample size. So now estimate the minimum sample size. By the way, I say that there is, you estimate minimum sample size, but don't be so adamant that, okay, if minimum sample size is 150, and if I get 160 data, that is a good sample. No, sample size is just a number. That minimum you should try to collect this much data. But again, it is always advisable to understand your sample and then collect data from every part of your sample. If your sample is, let's say if your population is more heterogeneous, then you should try to account data from every group of the population and make a very diversified sample. Now here you can simply say that, just a second here, let me a priori, and here you can simply take this linear multiple regression fixed model, select this, keep this as t-test only timing, and see this f square 0.15, error probability 5%, and this is 90%, just calculate. So how much minimum sample size is required? So it is giving you total actual sample, the total sample size 74. So with this arrangement, with effect size 15 and error probability 5% and power 95, you require minimum 74 sample size. So you require minimum 74 sample size. 74. Just remember, this is how you calculate the minimum sample size using G-Power software. By the way, there are n number of software which are available online to compute minimum sample size. Okay. Now my data is 99. So if you divide 99 by 74, if you divide 99 by 74, 99 divided by 74, so 1 point something will come, no? 99 divided by 74, 1 point something will come. It means there will be more than one unobserved sources of heterogeneity in my data set. So total sample, let's say if my sample size, I'll take your doubt, don't worry. Let's say my original sample size in this data is 268. And G Power software says that minimum sample size is 74. So just divide 268 divided by 74. Yes, okay. So let's estimate here, calculator, and if you divide 264 divided by 74, the answer should be, there should be minimum 3 to 4 unobserved heterogeneity in the data set. So this is how you determine that how many maximum unobserved sources of heterogeneity can be there in my data set. So total sample divided by minimum sample size. So you get to know that how much unobserved sources of heterogeneity max to max can be there. So this is one formula method. By the way, when you read papers on physics, they use all this BIC, Akai, and so many other indicators in order to estimate that how many clusters are there in my original data set. Clusters means unobserved heterogeneity. Yes, but we are not estimating unobserved heterogeneity using PHYMIX-based procedure. We are using REBUS, response-based unit segmentation. Smart PLS has this PHYMIX. Okay, but my understanding says that if you explore CSEM package, you can account for this unobserved sources of heterogeneity in the data set in CSEM package. But CSEM package, again, I say it's very technical in the sense that many times you don't get the output itself. But CSEM package will test model robustness checks, but provided some reference material if you can get, and then it will make a lot of sense. Okay. So now what I'll do, all of you just pay attention. Huh? I'll come to my syntax. Where is my R studio? This is my. Achha, any questions are there or what? Okay, some book somebody has uploaded it. Okay. So now friends, line number 130. This is vector groups, and the command is hclust. Now if you want to see, means PLS-PM. See, this is PLS-PM, and put 2 dots. Sorry, PLS-PM, and put 2 dots. So here there is one function called hclust. So there is one more method of calculating how many clusters are there in my data set. So somewhere it must be there, hclust. EFGHIR test reverse hclust. No, hclust is not there. GH. Just a second. Sorry. This hclust you will not find here. You know why? Because see, there is one method that understand the minimum sample size and divide it by total sample. You can have a guess that how many unobserved heterogeneity could be there. Yes, okay. And another method is that this is hclust, hierarchical clustering. You know, in marketing there is a technique called clustering. So use the clustering technique, and this is the command boot estimate $1 means this is the vector, and divide by and $scores. You are extracting the scores of the construct. And then method is var drd. So I'm writing this line number 130. Yes, and let me plot groups. Can you see this? So how to identify unobserved clusters in your data set, unobserved segments in the data set? All of you just pay attention. Yes, okay. Now let me fine tune it even better. Let me color this. Okay, now looking at this cluster dendrogram diagram, can anybody identify how many clusters are there? You can see this pink line. By the way, this is just a 99 data set. How many clusters could be there? If you look from top, it seems there are 2 clusters. If you look from top, it seems there are 2 clusters. Entire data is divided into 2. But if you slightly look, if you focus on the pink line, it will say 1, 2, 3, 4. It says 4. Means 25 के 4 हो सकते हैं. If you look from down, 1, 2, 3, 4, 5, 6, 7. Again, this is very confusing. This is very confusing. So now people draw this cluster diagram and then they interpret how many clusters will be there. So below this line, this red 10 line is red pink line is there, no? We should try to identify clusters. But again, this is very confusing. I would not recommend to identify clusters looking at the cluster dendro diagram. Even if you're looking cluster dendro diagram, we should look from the top. Then perhaps it will make a lot of sense. Now, see what I'm doing. Now, this is the function. This is the function Rebus PLS. Rebus stands for response-based unit segmentation. I know this is slightly bouncer for many of you, but I would request you to read the book of Professor Gaston Sanchez, particularly checking unobserved heterogeneity. There he has given step-by-step procedure. Since I've used it, I know this. Okay, now many of you might not have used it or might not be using in your PhD thesis, but still you need to go and read the material, and all the syntax and all is fixed. So this is my vector or out what you call as output, and this is the command, and I'll simply write the bootstrap model here, and let me run line number 136. So when I run line number 136, friends, all of you just pay attention. Can you see the screen, all of you? Loveji, can you see the screen?
Yes, sir.
Gandhali, we are on the same page.
Sir, I have one question, sir.
Yes, go ahead. Yes.
Sir, in generally what I heard from someone from stats departments, and he was telling me that dendrogram generally we prepare for cluster analysis, and through this we can identify that what are the relevant questions in your questionnaires. Is it so or not, sir?
See, in order
clubbing the clubbing the questions, sir. Like suppose two questions
actually,
are giving the same answer.
For clubbing the question, Loveji, there is a technical factor analysis. So when you do a factor analysis, no, what factor analysis does, it clubs all the questions which are very similar. But
true,
if
sir.
you want to club the responses, cluster analysis is used for clubbing the responses which are very similar. So what you can do, you in your classroom, Dr. Loveji, you simply ask people's marks in a particular subject and then create clusters. So you'll identify certain people are very scotchy, certain people are average, certain people are below. Then you can create. See, this clustering is a technique available to accumulate the responses. So responses which are very similar, they will be clubbed under one. So I don't think so that clustering can be used for grouping questions. For grouping questions, there is a technique called PCA, principal component analysis, or factor analysis. Okay.
Correct.
And this dendrogram is for clubbing responses which are very, very similar. But again, no, it's very difficult to interpret it. And even if you're interpreting it, see from the top. See from the top. Okay. So yes. Now if you can see, here it is asking when I ran this command, line number 136, it is asking give me a number. Give me a number. If I write number 5, it will show me error. Why error? Because see, there are no 5 clusters. There are no 5 clusters in 99 data set. So it is throwing me error. Yes, so again you need to run this. Again this is trial and error method. Huh? This is trial and error method. Again run this. Yes, okay. Oh, sorry, this is unobserved output. Sorry, this one. Run this. Now again it will throw give me some number, right? 3. So this is showing error. Yes, press upper arrow key. Or let's say unobserved. Give 2. No, again, just a second. Here you need to run this. Object unobserved output not found. Why? Here it is giving me. Yeah. Here it is giving me. And now it is asking me, give the correct number. Now you know this, we had the minimum sample size 74 and 99 divided by 74 max to max, there could be 2 clusters. So when you give 2, it will give me the answer. Yes, it's reading 1 item. So max to max, there are 2 clusters in this 99 data set, unobserved heterogeneity. And now let's account the structural model for these 2 segments which are unobserved. Yes, okay. Now, technically, you should go back and trace all the unobserved sources in Excel key. What is the difference? Now here, I will simply run this command. Now here, can you see? I am getting output based on the cluster. All of you just pay attention. All of you just pay attention. So I ran line number 140. Now see, this is response-based unit segmentation in partial least square path modeling. So number of segments 2. It is saying there are 2 segments, and these are all stop criteria by default. See, so this is rebus segmentations. And in the first group, there are 49 data set, and in the second group, there are 50 data set. So there is some difference in group 1 and group 2. And here you can see the path coefficients. All of you just pay attention, see the path coefficients. For LMX and OI, this is the path. And for group 2, this is the path. Not much difference. It means for both the path, there is LMX and OI relationship is significant. For both the classes, sorry, for both the segments, class 1 and class 2, beta is thick. For LMX OCB, just pay attention. For class 1, this is positive, and class 2, this is negative. Now see the difference. Why you should go for response-based unit segmentation or identifying clusters within the data. Now for one group, LMX OCB is positive. For the second group, LMX OCB is negative. Now just try to find out why for the second group, LMX OCB is negative. Why these people are not influenced by the quality of leadership. Just try to find out. Then OI and OCB, okay, see here there is a very high and here there is very low. But I think there is some dichotomy here. For first group, LMX OCB is significant. For second group, LMX OCB is not significant. What you do in multi-group analysis, my friends, exactly you are doing in rebus, but with unobserved heterogeneity. These are unobserved heterogeneity, and this could be because of psychometrics or some other reasons, which is not known to you and which is not part of your questionnaire. Just remember this. And loadings is okay. We're not going to see the loadings and all. And see the classes, yes. See the R square. R square, see, focus on this. The R square for OCB, overall model, is 61% and 70%, almost same. And see the goodness of it here is high. So are you getting how? Now here you can interpret. Huh? So this result, can you see summary? So this vector, I put it here and you can extract the global model. By the way, don't get confused. Even if you don't understand, just relax. Everything is there in the Gaston Sanchez books. One by one, slowly and steadily has given mechanical steps. So run this line. This is saying, let me run this line first. And then this is the overall result. This is the overall result that we saw after the bootstrapping. Huh? This is the overall result. Yes. And now you can calculate for class 1. So this is the overall result for class 1. Pay attention. Let me remove this. This is the local model. Local model means for class 1, you can calculate all the separate structure analysis. So number of cases 49. In next will be number of cases will be 59. And here you can see LMX OY. This is total effect. Here you can see the direct. Where is the direct effect? See, here is the direct effect, inner model. LMX and OI is significant. Yes, P value is very small. Then LMX and OCB is significant. For first model, yes, it is significant. P value is small. OI and OCB is significant. Yes, it is small. You can see the construct correlations. Now, similarly, you can go for the 51, another observation, local model 2. If you go for local model 2, here you can see LMX, and this is not significant. See, this is 2.52 E, 0.01. If you multiply, it will not be significant. And here it seems significant. So this is what we saw earlier, no? This is what we saw earlier. And here you can see the goodness of it. So you can account for unobserved heterogeneity using this. By the way, my friends, there is one interesting argument. See, if there are unobserved sources of heterogeneity, if you run multi-group analysis, you'll find there is a total global model and there are local models. Now, if you account for unobserved heterogeneity, your model, there will be a lot of differences in the structural relationship in multi-group and other stuff like this. Normally, people would like to comment that yes, there are no observed sources of heterogeneity in my data set. People would like to comment, my friends, please notice. People would like to say that there are no unobserved sources of heterogeneity in my data set. By the way, when I was working in my PhD thesis, I used Rebus because I was doing with PLS-SEM package. And I was very fed up because I was not very clear ki how many clusters are there. 2 clusters, 5 clusters. And at that time, I had very layman's understanding. So see what I did. All of you just pay attention. If I can show you this thesis, see what I did. So here, if I can go for unobserved heterogeneity. Yes, let's read this. This is my PhD thesis. Let's read this. So assessing heterogeneity. Hope it is visible to everybody. Friends, even if it is bouncer, be it bouncer. Yes, but just flow with the flow. When you start writing your codes or when you start performing it slowly and gradually, there are many sources by which you can learn it. But at least you should be sensitized. Yes, after structural model after structural model result, after PLS predict, there are certain model robustness checks. Now, even if you stop at PLS predict, it's fine. Your paper can be published in A-star and A category journal. I just show you European Business Review paper. Somebody has just stopped up to PLS predict. But now there are some reviewers who might ask you, okay, go and report the model robustness checks. Then in that case, you can't say no to your reviewer. By the way, all this model robustness checks that you are learning in R, it's very simple in Smart PLS4. Just drag and drop. But since we are doing it in a longer route, let's understand. So here what I did, all of you just pay attention. Here I did all. And I found one paper in IIM Ahmedabad. Because earlier when I was writing this PhD analysis, it was a Corona time. And in my college, there were not access to many reference material, like Emerald was not there, Francis and Taylor was not there. There was only one EBSCO, and even from house, you can't access it. I was teaching in an undergrad college at that time, Corona time. So I had one portal from which I can download paper, and the name of that portal was Z Library, or what you call as what do you call that? Z Library, what do you call that? Skyhub. So I used to download papers from Skyhub. But Skyhub had a very similar argument that you type, you get every time the same paper. So I was not knowing how to account for unobserved heterogeneity, whether it is there in my data set or not, because there are 268 sample size in my data set. So September 2021, I went to IIM Ahmedabad. So because I have the alumni status of IIM Ahmedabad. So my card is there. So I wrote an email to the IIM Ahmedabad librarian. I said, I'm coming for my research purpose. So they arranged my stay and all for 10 days in the campus. So when I went to the campus, they gave me access to Wi-Fi in my computer. So the moment IIM Ahmedabad gave me access to Wi-Fi in my computer, their entire library was there in my laptop. And simply I was typing unobserved heterogeneity, doing literature review. And I came across this beautiful paper which addressed my issue. And I want to share you this. Okay? Because IIM Ahmedabad spends around 7 to 8 crores on their library annually compared to many other institutions. That's why it's a beautiful place for research and all. IIM Ahmedabad. You should definitely go and study there maybe sometimes. By the way, IIM Ahmedabad organizes one wonderful faculty development program for research scholars and faculty members. And it's there in the month of April to May, 2 months rigorous program for faculties. So they charge around 2 lakhs, around 2 lakhs something. It's there on the website. Just check it. I don't know the exact fees, but you should definitely do that. Faculty development program from IIM Ahmedabad. That will surely help you and will train you as a researcher. I would recommend you that because I did it 2015, and at that time it was a 4-month program. We had to go and live in the campus, and all best of the teachers, they teach you. And that is how I got accustomed to some of the teachers there, particularly my guru, Professor Vishal Gupta. Okay. Now, all of you just pay attention here. So when I was just searching it out, I came across this particular paper. Let me share you this paper. And this paper is by, just a second. And it addressed all my concerns related to this Vinci and Trincheria 2008. Yes, and there was again by, so this paper says, I'll show you. Just let me read this. And this paper I'll share you. So I ran all this dendrogram, but I was confused. So again. In the subsequent analysis, which involves iterative process, number of segments were fixed as 5 as generated from dendrogram with 0.05 default stop criterion. I said 5. How 5? 1, 2, 3, 4, 5. I look from down. So there are 5 segments. So 268 divided by 5. Okay. So here you can see the output. Here you can see the output. There are 5 classes. In first 26, second 48, third. These are unobserved heterogeneity. And these are their separate coefficients structural wise. Reported everything. Then this is their model fit indices in robust. All they separately have reported it. What are their R square, different R square, different. See, this will increase complexity. And and then this paper came to my rescue and it says, let me read this. The rebus solution generated path coefficient, loading and other quality indices separately for each of the 5 classes. However, quality of the local model is assessed using global quality index, which is reformulated goodness of fit index. So now how you assess the global quality model index? Let me show you. It was there here. It was there here. So if I run this, if I run this and simply type 2 and enter and later on type this, here you see, here you get this, here you get this matrix global quality index, GQI. Now see what I have written, and this is cited by a paper. So however, quality of the local model is assessed using global quality index, which is nothing but GOF only. So if the GQI index is higher by at least 20%, then the GOF index of the global model, then the local model solutions are found to be satisfactory. Means if the difference between GQI and GOF for the global model, if the difference is higher by at least 20%, see this is GQI and this is GOF for the global model. Let me mark it. Let me mark it, my friends. This is a very important line. You should not miss it. GQI and let's say GOF index for global model. So you and this is the threshold, higher by at least 20%. Yes. Now pay attention. What is my global quality index? This is 58%. And let me run this global model. Let me run this global model. If I run this global model, what is the GOF? The global model is 0.5441. And if I go up, this GQI is 58%. The difference between 54% and 58% is how much? The difference between 54%, 4%. It means there is no unobserved heterogeneity in my data set. Getting? See I would like to comment. I would like to say that my results are robust. There are no unobserved heterogeneity. So this paper, this Vinci and Trinchera, very old paper, came in my defense. Because see, when you do an analysis, you want everything perfect, fine. Yes, okay. But again, go ahead and see what Vinci and Trinchera have written ahead. So here you can see, however, the GOF measure of the global model were reported to be 54 and GQF of 5 segment were 0.606. Means for 5 segments, in 268 data, there was 5 segments. In the present model, there are 2 segments. So the difference between this is not more than 20%. Thus, the increase of GFI over GOF is only 10.79%, thus demonstrating that rebus-based partition does not sufficiently outperform the global model estimates and prediction. It means the rebus package is not that. It means I'm saying that rebus partition is not significant. Therefore, model robustness for unobserved heterogeneity based on the comparative matrix of GFI and GOF is adequately established. Yes, I'm saying it's okay. Further, it is concluded that unobserved heterogeneity is not a concern in a sample, and the global model means overall results, sufficiently represents the accurate relationship in our hypothesized model. So I am saying based on rebus and based on this global quality index, the difference is not more than 20%. So I am saying that unobserved heterogeneity is not a concern. This again I have done using rebus. But when you go and use Phimix also, you should try and see. By the way, Phimix is more robust, my friends. Phimix. But I'm yet to explore Phimics in unobserved heterogeneity by using Phimics method in RStudio. I'm yet to explore it. But since I have promised that I will be covering model robustness checks, I'll definitely want to show you. So Phimics, I have uploaded couple of paper. Yes, Phimics and all. So please go and read some of the paper. And particularly this 2016 paper. No, not this is not the paper. And treating unobserved heterogeneity in PLS-SEM, a multi-method approach. And they are using all this Phimics method. By the way, Rebus is also a method. Huh? Rebus is also a method. And Rebus also accounts for unobserved heterogeneity. Now let's say when you're working on RStudio or R, then Phimics might be an issue with seminar, or you won't know how to calculate with CSEM. Then you should write that unobserved heterogeneity in the model was accounted using the Rebus function in the PLS-SEM package. No harm in writing it. Okay, does that make sense? Does that make sense? Are we on the same page? Are we on the same page? Let me take doubt. Okay, come on, let me take doubt. So we saw non-linearity effects, and second we saw Rebus, response-based unit segmentation using PLS-SEM package. Come on, anybody has doubt, you can ask me. By the way, 10 participants are there. I'm so happy, so glad that you are there right from the start of the day today at 6 o'clock. I'm very happy. By the way, anybody has doubt, you can ask me. There's no wrong question, and I don't claim that I know everything. Yes, okay. So there is one comment. By the way, is it bouncer? Is it bouncer? Aditya ji, is it bouncer? Okay. Yes. Aditya ji, is it bouncer?
A little bit, sir.
Okay.
Because this is very much new concept for me, as I am from applied statistics.
Okay. By the way, Aditya ji, please stick with seminar package. Huh? It's easy, seminar package.
Yes, sir. Yes, sir.
It will help you, and stop till PLS predict. If you're, let's say, if you find problem, stop till PLS predicts, but nothing harm in knowing it. But
Yes, sir.
Tomorrow, 10 years down the line, you think your level of evolution evolves and you become even more matured. Then you want to check other methods also, and you want to report also. Nothing fine. And see, I always believe in the saying of John Maynard Keynes, that in economics there is always two things. One is there is short run, and one there is long run. So in short run, everything will be inelastic. Economics, in short run, everything will be inelastic. Means short run is very fixed. You can't change much in your short run. If presently you are poor, but in long run you can be rich. Nobody knows it. So John Maynard Keynes, he was an economist. He got a Nobel Prize, and he said, in short run, everything is inelastic. In the long run, everything is elastic. So as a researcher, today you might not be that advanced, you might not be that high, but believe in the long run will be elastic. You'll have many papers under your belt, or many feathers in your cap, even A star and A. Believe in the long run, and just be focused on your excellence, no matter, even if your journey is slow, even if you're walking a snail pace, just relax. Just work on your consciousness. Just work on the level of your evolution. Again, I say we all are at different levels of evolutions. So we need to constantly work on the level of our evolution. Please remember this. So not this learning what you are learning right now, it might not be useful in your present research or present PhD thesis, but maybe let's say 5 years down the line, 6 years down the line, you will remember, yes, there is a Rebus function which is there in PLS-SEM package, and using that particular package, we can invoke it. We can definitely understand the segments in the data set. In my data set, that you can definitely understand. By the way, Rebus package can also be used to comment whether your sample is homogeneous or not. Sample should be homogeneous so that you can make a good comment, and that is an argument. If your sample is homogeneous, no need to go for multi-group analysis also, if your sample is homogeneous. Okay. So that's why not many people talk about MGA. Few papers report about MGA, and people assume that my sample is homogeneous, though this itself is a very wrong argument to say my sample is homogeneous simply on hearsay. Rather, it is always better to support it with some stats. Okay. So this is how we saw the second robustness checks. Okay, shall we proceed? So last 15-20 minutes, not more than that. Okay. By the way, endogeneity, let me show you how to calculate endogeneity. But I don't have the syntax written here. In my, if you see my this screen, I have just stopped till unobserved heterogeneity, rebus package. Okay. Now remember, I took you to this particular place or this particular site, PLS.net. Yes. Okay. So let me bring this down and see, focus on this particular site. Yes, this is the site that we saw, PLS.SEM website. So whatever new developments that happens in the world of PLS-SEM, it's reported here. PLS-SEM.net, this one. Okay, just see the screen. And now there is downloads. Can you see downloads? You can see downloads. And in downloads, there is something known as, see this, Gaussian Coppola R code example of, now here I'll download this. Just focus on this. Now, to check endogeneity, the developers have given us the R syntax. Yes, and see, they have given this. If you go down, so they have given data for the Gaussian Coppola example. By the way, see, if you want to check endogeneity, you have to create copulas. Now, copula is some algorithm that it is given in this particular PLS-SEM method, and there is one method which is known as which is also known as Park and Gupta Gaussian Coppola approach. To check endogeneity, we use one approach which is known as Park and Gupta Gaussian Coppola approach. So here you can see data of the Gaussian Coppola example. They have given us data. You can use this data and check for endogeneity in your model or in endogeneity in your data set. Now, endogeneity becomes a concern when you have certain variables which are missing. Let's say you're working on teams, or let's say you're working on entrepreneurship. If you miss certain important variables, then endogeneity will be a problem. The error term in the predictor variable will be associated with the error term in the dependent variable. Yes, okay. So now here they have given this R code, and here you can see this R code for Gaussian Coppola approach. And let me download this. So this is entirely, if you can focus here, it's an entirely R file. .R syntax it has. So let me just download. Can you see this? This is a very big code, very big code. Now here you need to go and fit your all your. So by the way, this hashtag that you see, these are all just comments. This set with, it is nothing but changing a working directory, and you need to import install a package called car. So how to install a package? Car stands for companion to applied regression. So you need to just install packages and double inverted comma car. Okay. And then here you need to function to create copula. See, all this, we simply need to run it. Don't listen to anything, simply run it. And here they have taken corporate reputation model, comp like SUSA. Can you see? Okay, let me do one thing. Let me teach you this in a separate. Okay, so there is seminar package. Yes, in seminar there is something known as corporate reputation data. Can you see this corporate reputation data? This is the corporate reputation data which is there in this seminar package, my friends. So what these authors have done, they have simply create copulas. Yes, okay. And see, they have given all the syntax. I didn't write the syntax, my friends, because it's very tedious. I need to copy it and change it accordingly, and then I need to use it. Now I'll teach you one method, and I want you to go home and run this code on your own by downloading on the website, by changing the syntax. It's a very long, lengthy code. And wherever you see this hashtag, that is comment, forget it. You simply need to run it, cut, simply run it. Or what you can do, simply select all and just run it. And it is saying it is error. There is no working directory. No, see, this working directory is my separate. No, this is not the working directory. So you need to customize this. The authors have given you the R syntax, but you need to slightly customize it according to your data. Again, you need not create this syntax. Syntax is fixed, my friends. Syntax is fixed. You can't create the syntax, but you should run it for for this particular model. Yes, okay. Let me run this. Can I see and run this? No, it will not run this because I've not attached the corporate reputation file. In order to extract these variables, I need to attach all those things. Now, friends, pay attention. We are the last leg. I'll simply explain you. Then you can go and you can have your own copulas. So this is the same paper, Sarsted at Endogeneity. Screen is visible. Hello. Aditya, screen is visible. Kiran, screen is visible. Gandhali, Sonam.
sir.
Yes, sir. Yes, sir.
Sonam is there. Sonam is there.
Yes, sir, I'm here.
Okay, okay, good. So we'll have an interaction session after this gets over, and we'll chalk out a strategy how we can collaborate. If interested, I know nothing force and all it. By the way, everybody has paid for the workshop. Yes. Okay. So endogeneity, my friends, let's reflect on it. So what is endogeneity? It is because of missing construct in your model. So do a thorough literature review when you go for model building. Again, I'm going back to the first lecture. Building a model is an art. You have to be very creative in building a model. Simply not taking three constructs and simply running a model and see anything you put in SEM will definitely give you something. No. See, if you go to doctor and doctor tells you go and do the blood test, something or the other will come out. If you do your body checkup, no, something or the other will come out. Go to a dentist, dentist will say cavity hai, ye hai, wo hai, plug hai, he will say. So software, you put anything, something or the other will come out. Software is not a big thing. Learning SEM, learning PLS-SEM, learning multi-level model, learning SPS is not a big deal. What goes before data collection, that is very important. Very important. Model building or theorizing it or creating your own matrix, how people are behaving. This is very important. That's why try to, again, just a food for thought, try to go beyond model testing. You see, I'll tell you when somebody who asked me, God knows who asked me. Then now there is one OB textbook by Stephen Robbins. So there is one Fred Fiedler theory. It doesn't talk about model only. It talks about that under which circumstance a leader will be successful. I really enjoyed that theory. No model in that theory. Model must be there, but such a wonderful theory, my friends. You should definitely read this Fred Fiedler theory. Again, I'm slightly mispronouncing it, but Stephen Robbins, there is a book on OB, and in that there is a chapter on leadership. And Fred Fiedler, there is some model on contingency leader, something is there. Okay, now see, all of you pay attention. Huh? Now, let's say if we go to such environment, our personality, let's say that there is one work environment where there is high power distance orientation. Let's say there is one environment where it's not that easy to meet the leader and the leader is not available. And let's say even if you have work, the leader will not give you time. So there are certain personality who are egoistic. They will not be successful under such environment. They are bound to be at loggerheads with the leader. Yes. Now this I can say because my work is on LMX. So see, again, there are certain conditions for you to flourish. If at workplace, there are certain conditions which are not there, and if your personality is not able to digest it, you are definitely a misfit into that particular place. And you need to take a hard call. Okay, this is not the place for me. I should be on my own, or I should find the right place for myself. So Fred Fiedler model, I would suggest all of you to read, and it goes beyond model testing. And wonderful, they have created matrix, Dabba and all, and they have tried to understand that when will leader have a very high power. You see, in government organization, leader can't exercise much power because government organization, if you see why for aided jobs, particularly people who are working in aided colleges or grants in aided colleges or universities, because it's not that easy to fire a teacher in an aided institution. A teacher might go to court, he might go to some other places and challenge the leader. Their leader will not have much power. But in private sector, leaders have much power because they believe in hire and fire. So employees will not have much power. So context matters, situation matters. Okay. Now again, I'm slightly deflecting. Why Mukesh Ambani was successful? Now you see Ambani family is in news and wonderful family they are. Yes. Why now when people why Mukesh Ambani is successful? The biggest question is son of Dhirubhai Ambani. Now why Dhirubhai Ambani was successful? Because his time was successful. So people are successful because of context. That's where the question of moderation comes. है ना, तुम्हारा सिचुएशन बोलते ना कि समय बलवान होता है. Again, let me quote you from Mahabharata. Arjun was defeated by ordinary people when Krishna died. Yes. So Arjun thought I am very powerful. No, it was the situation that was powerful in the battle of Mahabharat. Krishna was there, Hanuman was there, and situation was right for Arjun to win. But when Krishna left, situation was not right for Arjun to win. Despite having his powerful bows and arrows, he could not win. So people win because of context. And this, when you talk about context, you are actually talking about moderator. Certain conditions are there because of which you are. Okay, let's go to Kiran. Kiran has a doubt.
So I just wanted to ask citation for this Arjun Wala example.
Citation. Okay. Citation is Mahabharata. And after by Srimad Bhagavad, there is a beautiful textbook, Srimad Bhagavad, and after Krishna dies, Arjun goes from Hastinapur to Dwarka to meet Krishna, and he gets the news because at that time there was no phone, tar, letters, and all. From Hastinapur, Arjun goes to Dwarika, and when he goes to Dwarika, he gets the news that entire Krishna family is destroyed. Even Krishna is killed. You know, Krishna was killed. He said Krishna is killed by some accident, and Krishna is died. So he could not digest that fact. So he started coming back to his house, and in between he was attacked by tribal people, and there he could not defeat the tribal people, and he lost the war. And but somehow they relieve him, and he goes to Hastinapur, and he narrates to all his four brothers, that Krishna is dead, and he is no longer there, who supported throughout our life. And all five brothers said, okay, let's renounce this world, and let's go to Himalayas and sacrifice our lives. So that is beautiful. Even if you read this book by Devdutt Patnaik, Mahabharata by Devdutt Patnaik, he has given this citation.
Okay,
Yes.
sir, I please don't mind. I asked citation because I'm writing a paper on context only. First time I tried in a good journal, but they rejected, say, but because they did not understand what is happening in the paper. So now I understood that I probably my arguments are not that strong.
Yeah.
That's the only the review that I have got from the editor, make the argument strong, though the research question is very good. So somewhere I felt that they have rejected, but they want me to revise it properly and then again get back to the same journal. So that is
Yeah.
why this is a good example that I can give on context in that paper.
Good.
Thank you, sir.
Okay. So, okay, let's rest this discussion and come to endogeneity. By the way, endogeneity, it's for you to practice, all of you, my friends, and simply read this stuff only from here to here. That's it. Some three paragraphs. All of you just pay attention. Huh? The consideration of endogeneity is the key issue when applying the regression-based method such as PLS-SEM. I said no, PLS-SEM is nothing but regression-based method. All of you just pay attention. Simple. Endogeneity in PLS-SEM occurs when a predictor construct is correlated with the error term of the dependent construct. Sorry, I made a mistake. What I said the error term of the predictor variable is associated with the error term of the dependent variable. I made a mistake. No, actually it is the predictor construct, independent variable, correlating with the error of the dependent variable. Here I slightly made a mistake, but just I stand corrected with this argument. This implies that the predictor construct not only explains the dependent construct, but also its error term. Your independent variable is not only explaining the predicted variable, but also the error term. No, this is the problem. Now, again, here you see they have created this copula. All of you just pay. Now, this is the model, my friends. Please pay attention. There are four constructs. Now, focus on this construct ipto. Apart from ipto, all are independent variable. Apart from ipto, all are independent variable. Just remember this and see how they have addressed this endogeneity issue. They have created copulas, huh? And see. So first, they have created copula for ATT, then created copula for trust, then create copula for com, then again ATT trust. Sorry. Now I'll leave this topic in limbo for you to practice. Then again copula for 2, and copula for 3. To put it simply, my friends, everything is there in the R syntax. See, now what you should do, first you have to run a regression. Ipto is your dependent variable. Ipto, yes. Trust, ATT, and com are your independent variable. ipto, again I repeat, ipto is my independent variable and ipto is my dependent variable and 3 independent variable. So along with this 3 independent variable, first I will create copula for trust. Second, again I will run a regression equation, ipto as dependent variable. Now I will use the 3 independent variable. Now I will create the copula for ATT. Third time, again I will run the regression, ipto as the dependent variable, trust, ATT, com as the independent variable, and third time copula will be for COMM. Then second time, again I will run the independent this regression model. Now I'll create 2 copulas. I will create 2 copulas, one for trust. Let me take this. One for trust and second for ATT. Third time, again I will run the ipto, and this time copula will be created for this and this. Then last time I will create 3 copulas. Copula ऐसा लिखा था, trust, ATT, C, com. Here you see, just read this paper, my friends. This is a very simple paper. And here you see they have created copulas. All of you just pay attention. First time, they ran a regression with all the 3 independent variables and created copula for ATT. Second time, my friends, they ran all, again once they ran equation and they create copula for the second independent variable, trust. Third time, again they ran a regression model and they created copula for com. Can you see pattern, logical reasoning? 2, 4, 6, 8. After 8, what will come? 10. Then again they are running regression. Now this time they're creating copula for 2. ATT trust. Now they are running a regression and they're creating copula for this. Friends, again they are running a regression and creating for these 2. They're changing it. And lastly, they are again running a model and they're creating copula for 3. So see how see the pattern of copula. Pattern of copula. First was 1 copula. Yes. Second time 2 copulas and last time 3 copulas. So here first copula ATT, then the second independent variable com, and I think one more was there. They keep on changing them. Then 2 copulas, then 3 copulas. Lastly, they created this 3 copulas. And simply it's regression, and they're reporting the p-value. And wherever you find this copula is significant, see, here it is significant, no. It means endogeneity is not there. अगर ये आपका copula significant आया ना, see, if this is significant, no, it means there is endogeneity. But see, the p-value is greater than 0.5, so no endogeneity. No endogeneity. Again, this is simply regression, my friends. You have to create copulas. Again, this no endogeneity. Endogeneity नहीं है, अच्छी बात है, endogeneity नहीं है. Again, see, no endogeneity. Again, see, no endogeneity. No endogeneity. Again, see, no endogeneity. No endogeneity. Yes, okay. No endogeneity. No endogeneity. No endogeneity. No endogeneity. No endogeneity. It means there is no endogeneity. Structural model is robust. By the way, in their example, there is no non-linear effects. Then there is no unobserved heterogeneity. No, I have not read it. And third is no endogeneity. It means result is robust. Result is robust. By the way, observed heterogeneity, I think so they have written about it. It's there. See, number of segments. And they have used Phimics, huh? They have used Phimics. They have used Phimics, huh? More advanced. Phimics. Phimics. In Phimics, you will take all this model estimators, AIC, BIC, and all those things. And there are conditions. कब क्या लेने का? ये बड़ा technical process है. Phimics का. Simple है. कोई बड़ी बात नहीं. Excel में डाल के predict करने का. Very simple है. Just read about it. And lastly, they have concluded. See the conclusion. See, when you write such one paper, no, it's heavier than 100 paper of others. मेरे एक बहुत अच्छे प्रोफेसर बोलते थे, instead of writing 100 papers, write one paper which is heavier than other person's 100 paper. Okay, I'll stop here and I will take queries. Okay, my friends, honestly tell me, you got your money's worth or not? Hello? Hello? I think snake has bitten everybody. सांप सूंघ गया बोलते हैं ना.
Sir, more than I got more than amount
So
I
more
paid.
than what we have paid.
Okay, let me first stop recording this.